Okay, I just want to take a moment to thank everybody. We're having a little bit of a slow start today, but it's day one of a two-day kind of marathon, which we're going to do our best to share, I think, a lot of the work that we've been developing over the last 16 months. My name's Sparopoulos, I direct the DRL, and over the next 2 days, you'll be seeing a series of thematic research agendas that have been developed by staff and students working on complex problems from the scale of the city to the scale of prototypes, all unapologetically trying to explore how design can make a meaningful impact to a whole host of complex issues. It's very apparent that we live in quite complex times. The social, the political, the ecological. At the same time, the needs, and particularly very humanistic needs, are things that we need to kind of explore in all forms. And the research agendas that we've been exploring in particular have also tried to look at some of the implications around the technological advancements and how those can be kind of demystified and used at task to really deal with some of the challenges of urbanism and architecture today. We are, like every year, very humbled by the fact that we have a lot of distinguished critics that join us for what should be 2 days of conversation. We have this platform as a kind of open and conversational exchange that helps us also consider where the work has gone, where it's going, and some of the things that we can consider as we start the next generation of research next week. So as we sort of continue and trying to keep this a bit brief, there is a link that has basically the schedule and the agenda, project by project, of all of the projects, all of the bios of the critics at drl.aaschool.ac.uk. We have over 20 guests that are joining us over the 2 days, so I encourage you guys to just have a look at who's actually giving you guys the feedback. But for our critics, I think it's important, maybe in the words of each of the studio tutors, just to give a little bit of a direct brief to sort of frame the conversation. We have 4 studios, but they don't work in traditional sense. There's a lot of, let's call it hybridization, and basically in method and in practice as a co-teaching affair in the DRL. So we'll start with Anja's studio, who's been exploring mobile habitats, climate, volatility, meteorological intelligence, and resource scarcity. And you will excuse me because my eyes are failing me. So for all the YouTube fans, these are the terrible glasses that I bought. Our studio explores large-scale agile bionetworks as adaptive systems responding to climate volatility, resource scarcity, and social inequality. Moving beyond static and extractive models, the studio investigates fluid forms of urbanization that evolve in dialogue with planetary processes and human vulnerability. Through territories of scarcity, water-stressed regions, food-insecure landscapes, post-industrial sites, climate-threatened coastlines, post-disaster contexts. Pierre is painting a very optimistic picture of the future, as you can tell. The project is really looking at adaptive systems in a way to somehow not only mitigate, but kind of deal with the dynamics that are very much part of our urban ecosystems. Sajay Bushan's studio is looking at architectural intelligence for new cities. In Sajay's words, the studio treats AI in new cities not as parallel themes, but as mutually conditioning problems. AI provides new ways to reason about optimization, negotiation, and adaptation. New cities provide a domain where those capabilities are not optional, but essential. Rather than focusing on automation of design outcomes, the studio is concerned with locating architectural and urban design agency within both the technical details of AI and the use value of new cities. Patrick Schumacher's studio, titled with the sub-themes Mega Building, High Density Urbanism, and Co-location Synergies. In Patrick's words, the studio explores the mega building as a contemporary urban type, capable of delivering functional intensity of an entire city district within a compact three-dimensional framework. Responding to accelerated urbanization and the demands of the knowledge economy, the research investigates how extreme density can amplify social, economic, and communicative interactions through spatial co-location. The megabuilding is approached as a complex urban system composed of interdependent subsystems, including structure, circulation, occupiable surfaces, and envelopes. That's the abbreviated version. For the full version, please look at drl.aaschool.uk. All right, and for my studio, I've titled it Everything Intelligence, a short statement from myself. Today we find ourselves in a moment where new ways of thinking are emerging that open up questions about agency and intelligence within our wider ecology that sustains us. Our work looks at environmental and technological phenomenon as a means of supporting life. It examines, intelligence, both artificial and natural, with an emphasis in the non-human. The challenges we face today point to the need to prepare for a world that is becoming ever more extreme and unstable, whether we're talking about environmental, social, or political forces. The issues are planetary in scale, and they call for strategies that go beyond simply correcting past mistakes. They require us to actively prepare for what is to come. Intelligence is explored through research that examines architectural intelligence as a means to construct an evolving partnership with systems and an attempt to prototype new models of engagement. Okay, so all of those words are going to be given meaning through the projects themselves. Each project is given an hour, about 20 minutes for a presentation. The way that we've scheduled it is that we'll see 3 projects in our morning session. We'll take a break for about 45 minutes for lunch and continue with 3 projects in the afternoon. Concluding the event today, we have a keynote speaker that will be given by Claudia Pasquero from Ecological Studio, who will be presenting at 6:30. So with that, I'm going to keep this as short as this could possibly be, and pass it over to the first team. Please introduce yourselves, and thank you everybody in advance for joining us.
Good morning, everyone. We are Team Abridgeidge from Studio Bushan. My name is Atul, and my teammates are Fengling, Palin, and Lo. Our studio brief is AI for New Cities. We are exploring how artificial intelligence can drive urban and architectural decisions. At city scale, we are using reinforcement learning to test program allocation and growth. And at building scale, we are blending different programs and their flow plans using latent space. At urban scale, we are using reinforcement learning, where the AI places programs like education, industrial, or commercial, and residential, based on reward and penalty logic, unlike the manual allocation. Alongside urban decision making, we are exploring architectural flexibility through building shape AI. Instead of fixed building typologies, we are using learning-driven geometric systems where form emerges from latent parameters and constraints. This allows building to adapt to urban conditions, programmatic shift, and long-term change rather than remaining static objects. We are using AI not as a tool for generating images, but as a learning process that forms internal structure through data and feedback. Our focus is on designing this learning process and using it to inform architectural and urban decisions. We refer to the past projects of our studio, where teams Meta London and Party Cities played the game manually. We are playing these games using the AI with reinforcement learning. We separate AI methods by scale and intent from reinforcement learning and large language model for urban decision making to learning-based geometric systems with latent mapping for buildings. To create this workflow for our urban vision, we started with researching about top-down and bottom-up city growth patterns, and we found both the approaches have some shortcomings. Then we researched about Shenzhen, which is a hybrid of top-down and bottom-up. It started as a fishing village, which transformed into a major economic powerhouse. which was driven by top-down policy decision in 1980. And there was some bottom-up growth that happened during this period. The current statistics of Shenzhen shows population as 17.5 million, 2,050 square kilometer of area, and 0.5 Human Development Index. Shenzhen's growth was not the result of a fixed master plan, but a cooperative game between state and market. Government controlled land release and infrastructure, while developers and investors drove construction and employment. Shenzhen demonstrates that urban development is a dynamic process. Policies, land rules, and market actions continuously adjusted in response to economic outcomes and migration pressures. So urban form emerges through iteration and adjustment rather than fixed decisions made up front. Then coming to the site research part, we intend to propose our thesis using the research which reflects a hybrid city model of top-down and bottom-up as the most successful so far. We would like to not only bring the Shenzhen urban model, but also the market-driven strategy in London using education, research, and local industries, driving the urban economic and spatial growth. We are proposing Thamesmead and Barking as our site. This location is connected to the London City Airport and already existing Barking Riverside Station. And also TfL has proposed for extension of the DLR line by adding a new station to connect Thamesmead across the river. Moving further, we explored the educational and research potential of this area. We discovered that while there are some existing education centers nearby, they primarily focus on lower levels of education. There are no universities or advanced programs. So we propose the creation of a dedicated education zone that brings in students, academic institutions, and training facilities to support the industrial ecosystem. Given the site's strong connectivity and accessibility, we believe that focusing on high-tech industries alongside research and education could trigger a self-sustaining cycle of growth. As industries develop, they attract migrants, investors, and developers, not just increasing population density, but also enhancing the overall quality and productivity of the city. The close vicinity of London's Sustainable Industries Park and manufacturing factory groups make it suitable for high-tech industries park. On the opposite side of the river, we propose establishing a research center directly connected to the industrial zone. The industries will focus on production and manufacturing, while the research centers will focus on innovation, prototyping, and a new technological development. This creates a continuous feedback loop where research feeds production and production fuels further research. Overall, our aim is to build a framework similar to the Shenzhen model where industry, research, and education work together as catalysts for urban and economic growth. We believe that this integrated system has strong potential, especially in context rich in resources and opportunity, just like London. So then, first we used a scalar field to identify the main development center of the site. Based on the current conditions, we choose a multi-center urban structure with 3 transportation hubs as our starting points. We then refined the scalar field further, drawing a land value map based on these hubs and the river as a reference for development. To reduce uncertainty in the bottom-up slot selection process, we used vector fields to clearly define the initial slot choices.
Come to the game AI part. When discussing the emergency of the new cities, it's useful to revisit a classic problem in the game theory to better understand the challenge of the urban development. The prisoner dilemma illustrates how rational behavior can result in Nash equilibrium efficient urban outcomes. Even when better collective configuration exists, no agents benefit from unilateral divisions. This makes system-level win-win outcomes difficult to achieve through game dynamic alone. Drawing on Shenzhen's market-driven development experience, this project used the city game AI simulation to explore urban configurations guided by win-win objective. When we focus on the site with strong development potential, we identify the local council as the most effective agents. The council aims to attract the citizens and simulate the local vitalities. At the same time, as we discussed earlier, economically driven by the manufacturing agents target future profit opportunities, and nature became the second agent. This leads to the main game rules. The council owns the land and builds the infrastructure to attract manufacturing agents, and the manufacturing agents purchase the land, develop the buildings, and generate profit for further attracting population inflow, eventually forming a win-win new city. Under these goals, the role of the two agents become clear. The manufacturer agents focusing on the building factories and increase profit, while the council provides supporting facilities such as education and residence buildings. Each construction actions requires an upfront cost and generates a continuous return over time. In the game time-based rules, each month represent a step in which one agent can either take actions or skip its turn. Different land price, lot, and building types involve different costs and expect returns. We first run a manual simulation for one game cycle, testing different actions to explore their cost and benefits during each agent's turn. Different buildings and actions quantities can be selected, resulting in different profit and cost values. This approach turns complex architectural behavior into quantifiable game actions, giving the win-win goals a clear numerical basis. We then move closer to the real-world condition by introducing a dynamic land price field that evolves with urban development, creating a more realistic and adaptable game environment. At this stage, the uncertainty of the action and the multi-agent iterations made the conventional parametric method increasingly difficult to manage. However, this system naturally fits the reinforcement learning approach. Reinforcement learning is an AI framework in which agents interact with an environment under the predefined goals, updating their policies through rewards and feedback, and gradually improving performance through the repeated iterations. However, evaluating results purely through the numerical optimization is not sufficient from a design perspective. So we return to the theoretical structure of the prisoner dilemma. Policy collapse, which the model coverage on the single dominant actions can be understood as a negative Nash equilibrium, where no improvement is possible without changing the rules. In contrast, the emergence of the diverse strategy suggests that the system still has flexibility within the same rule set. Based on this distinction, we can assess whether the simulation results follow urban development logic and whether the addition rules are needed. This leads us to a two-axis evaluation framework for interpreting design outcomes. Using this framework, we implemented the game with the reinforcement learning. In the first iteration, there's a single reinforcement learning model controlled both agents and combine their rewards, which quickly leads to policy collapse and a single repeated action. The outcome showed low block size matching and low building type diversity. It's a negative Nash equilibrium and clearly has low design value. We then improved the model by switching the system to a multi-agent setup, where each agents learn only towards their own objectives. This separation of goals helps the model better to understand which strategy belongs to which agents. In this iteration, the agents no longer immediately covered to a single building actions. However, the system still produced results that did not align with the urban logic, such as the building away from the river and repeating the same primary building functions too frequently. This result still offered limited design value. To address this, we introduced action, unlock machinism inspired by the video game Red Alert. After the game reaches a certain development stage, the manufacturing agents can unlock the original buildings, which can provide the scaling benefits to existing industrial buildings. This machinism expand the strategy space. As the economic of the scale become relevant, the model start to favor a longer-term, high-return building types rather than short-term gains. However, due to the parameter setting, some tendency towards strategy clubs in buildings type selection still remained. We therefore fine-tuned the parameters. This thing is still extend out the parametric and extend to the training process. In the final building program placement simulation, the two agents select different building types and location based on the site conditions to maximize the overall beneficials. The council focus on the infrastructure provision and research, while the manufacturing agents supplies the industrial capacity. And building on the previous stage two-dimension function layout, we then move to a second stage of the game AI process. This stage focuses on the layer function with the individual buildings. Based on the main functions, we add sub-functions as retail, public space, and green areas, and define the rules based on the foundational compatibilities and the floor preference. For example, like the retail one prefer ground floors and should not be placed extensively on the top floors. The aim is to increasing the spatial richness and while maintaining the logic of the primary functions. We first test a lightweight AI approach using an actor reflection framework based on the large language models. Here, an actor and a reflector operate two agents using the natural language reasoning. Rules are provided directly to the reflector, which then guide the actor's next actions through the words. And this approach helps prevent the continuous prompt misunderstanding. However, relying on the textual correction makes it hard to fully avoid certain issues, such as excessive retail placement on the upper floor. And as a result, we returned to the reinforcement learning bike using the PPO method. In this setup, the reinforcement learning system update this policy based on reward feedback and gradually learn to follow the to follow the rules more effectively, starting from the negative total rewards. In the first episode, the model improves to nearly 4,000 points by the 1,000th episode training. Compared with to the LLM-based approach, the reinforcement learning models perform significantly better numerically and produce layouts that better follow the predefined rules. This suggests the general purpose LLM map without task-specific training struggles to operate the game effectively. Overall, as the system evolves, we take top-down rules by embedding the implicit rules that guides agents' bottom-up profit-driven behavior. This allows us to maintain design values, encourage the urban diversity, and ultimately move towards a win-win outcome.
In the process of understanding and applying reinforcement learning, we traced back to one of the earliest and most fundamental logics of AI, the multi-layer perceptron, one of the most basic artificial neural network models. It was Geoffrey Hinton who pushed the MLP from a theoretical idea toward a trainable model, which later shaped almost all deep learning systems used today. In 1986, Geoffrey Hinton published the paper Learning Representations by Back-Propagating Errors in Nature. This work was the first to systematically show that multi-layer perceptron could be effectively trained. Its function is to stack many simple computations layer by layer in order to learn complex patterns. An MLP consists of three main components: input layer for receiving data, hiding layer for extracting increasingly abstract feature through weights and nonlinear activations, and output layer for produce prediction or function value. In our work, we use the basic architectural element, plan shapes, as the training material, and described both the shapes and their transformations through signed distance fields. We interpolated between shapes to connect them, and found that during the MLP process, the hidden layer, the latent space, shows more greater possibility than simple interpolation. To make the latent space translatable into architectural terms, we extended a standard MLP by assigned relative coordinates to each representative area of the site, embedding them through potential encoding to map the low-frequency x and y coordinates into a feature vector with multi-scale frequency components, allowing the MLP to represent higher frequency geometry details, and giving each point an influence weight. The latent space was projected into 2D plan, forming a latent map. We selected four representative zones from the site and assigned four shapes corresponding to four main functions. These shapes were fed into the MLP, allowing the system not only to learn each input shape, but also to learn our intermediate state between them. From this map, we can see that any coordinate on the plan corresponds to a shape. Between the four representative points, the shapes transition continuously. Depending on distance, each location blends different features to different degrees. This transition corresponds to what the MLP learns internally and reveal potential shape grammar that are difficult to predict manually. Using this latent map, we extracted the shape grammar of our urban system. For example, in the southern part of the site, the city form developed gradients that made the urban language more coordinated. However, pure latent potential is not necessarily controllable. To make it usable for architectural design, we introduced the semantic into the training. Here, One semantic means one direction in latent space that reliably changes the output geometry. Using our 4 functional shapes, we assign 4 such directions with opposite means in positive and negative axis. Each direction corresponded to a planar transformation rule. Our game output produces multi-layers building with different functions. Within an architectural AI work, this allows us to combine 2D semantic map for different functions and assign different shapes for different floors according to programmatic requirement. We can then adjust the scale and use interpolation to convert them into architectural massing efficiently. Within the latent space, any axis can be assigned meaning. If we assign the z-axis to interpolate between multiple shapes, while x and y encode our semantics, we obtain a 3D latent space in which every points correspond to a shape. Once the relative location, floor, height are defined, we can derive the transformation path of its floor plans directly within this space. From an architectural perspective, for low-density building with the simpler function, we explored SDF-based plan deformations that enable openness or directional adaptation. For the mixed-use southern riverfront development, different position functions and floor heights produce a different latent space result. This approach not only accelerated from exploration, but did so in a way that remained consistent with functional and semantic reasoning in the architectural planning. From the resulting plans, we can then derive skeleton and facade according to an area of the protrusion or contraction. And similarly, in the industrial zone, by combining several different programs, identifying the corresponding latent paths, and performing efficient form exploration, we produced entirely different outcomes and subsequently modeled them with different architectural languages.
So we will now build our exploration with shape AI and SDF-based geometric deformation to propose a generative design strategy for rapid urban construction. Here is the Northern Educational Hub, designed as a mid to low density mixed-use campus. Education is a primary program supported by public area and small-scale retail, forming a cluster campus fabric rather than a high-risk district. At the urban scale, we use an integrated podium system together with roof and interfloor bridges to organize a continuous pedestrian network. This creates a clear flowing circulation span with high accessibility, while also strengthening daily connections between different campus clusters. By combining our openness formal language with SDF-based geometry, we can quickly generate low-risk campus buildings across different site locations and quickly produce program-specific floor plans. Here is the floor plan and program layout of a campus building. Larger continuous place supports teaching and shared learning spaces. Smaller distributed units accommodate cafes, retail, and public services. This image shows a self-study and shared learning space inside the campus core, emphasizing continuous spatial edges and open visual connections. The file system is differentiated by building height. Mid to high density buildings use an exoskeleton expression where structural order reinforces a strong vertical rhythm. Low risk buildings use a richer set of environment components to create variation in scale and a more human-centered experience. From the pedestrian viewpoint, the high zoning and its corresponding facade layers are clearly legible. Overall, the spatial experience follows a gradual flow sequence and finally transitions naturally into the riverfront edge. Then it's about the industrial park hub. The industrial hub is mainly composed of industrial and office programs with a smaller percentage research. Here is the floor plan and the program layout of industrial tower. And the district is organized as a hybrid system of lower industrial podium and mixed-use tower above. The upper floors combine office space with industrial and technology research. Skybridge connects the tower to form an accessible 3D circulation network, improving cross-building collaboration and strengthening spatial identity. The lower podium focuses on production display space and supporting retail. This then is about the research hub. The research hub aims to create a high-density, highly mixed future tech core, and each building is organized as a vertical mix. Here's a program diagram for one of the towers showing its floor plans and functional layouts, with search functions at the top and bottom with residents in the middle. And about the facade strategy, we use two facade types based on program. The resident drones use a layable facade with balconies, and the research drones use a more enclosed curtain wall system. This facade contractor makes the vertical program mix leakable on the city skyline and street edge. About the generation strategy, with a latent map, we can quickly generate towers of different heights across different plots, while mapping structure and facade rules at the same time. This improves iteration speed from concept to presentation. At ground level, the concept and blend podium create a more open, shared public base that supports interaction across the district. In addition, we experiment with positive and negative shape interactions. By switching between solid and void, the plan generated rich formal variations. With this approach, we were able to effectively produce complex skeleton building masses, greatly improving modeling convenience and speeding up the form finding process.
Taking the results from the Shape AI, we have worked on form work on molds that are 3D printed. The model image on the right shows the casted structure and its connection to the core. So the overall structure forms a series of parts that can be prefabricated and then assembled on the site, making the construction process faster. We also analyze the types of nodes and their numbers that are repeating in the structure. And further, we also found some ways to subdivide the nodes such that the formwork can be repeated as well. While making some prototypes for these models, we realized the removal of the molds can be very difficult. So we are using this method where we will be 3D printing the formwork and then casting it with steel reinforcement concrete. And these are some more attempts for the node casting. Further, thank you.
Yeah, that's all. This is some processing model about our building type, and this is exoskeleton studies. And this one is the game AI stage 1 reinforcement learning's growth process. And this one is the layout of the first stage, and this one is the second stage layout, and this one is with podium and real latent space. Shape AI generated. And this is also a concept exoskeleton modeling. And this one is a big for the latent space latent map generate by different shape quickly and generate a structure together with the building boundaries. And this is the research center clusters. All the buildings higher than others, and this one is for the high-tech industrials, and this one is for the education center, and this one also is some processing model. And this part is about the plaster casting, and we try to find some way to join the clusters, but still not so easy to control. So maybe 3GP is the best way to to do it, but yeah, that's what we have tried.
Hi, thank you for the presentation. I missed the first part, so maybe you have been articulating or already answering to my question. But a huge production, very beautiful model. The system you have been deploying seems very sophisticated in articulating the floor plan, but I was wondering what was the logic in articulating the master plan, because from the result, it looks like you're focusing on a sort of zoning system. And I was wondering why you are not challenging programs as research mixed with living, mixed with production, mixed with remetabolization of pollutant and so on and so forth, and whether the system you have deployed to so accurately study the floor plan could be deployed also at a larger scale to envision new way of living, possibly, or improvement to the current status of cities. I don't know if you're meant to answer or not, but...
So at the urban scale, we have 3 centers, and for each center, we have one dedicated shape to make them differentiate from each other. And even these shapes are changing as they go towards the waterfront, or even the buildings that are between the research and industrial. They are also getting blended, where the programs are also like blending together.
Thank you. I think especially at the beginning of your presentation, I was thinking that we all have to learn a new language, and that's the language of AI. And it's very difficult to follow, and to, my interpretation of the words that you used is maybe a different one to yours and to everyone in the room. And we're at different levels of understanding also this technology at the moment. So I think in some way there's a first step, which is just explaining these processes in a language that anyone can understand, without using words that are maybe misinterpreted or easily misinterpreted. So I think it makes it very difficult to follow the logic. But certain things I think are very clear and very interesting to highlight. For one, I feel that your experience of setting up the model, so your question around the program is basically rooted in the fact that this was a definition that the team made at the outset. They created those centers, and any simulation, and AI is no different to that, starts with us humans defining the boundaries of the simulation. We tell it what it should focus on, and we basically give it its underlying intent. And then all the machine does is, through reinforcement learning, amplifying that intent. Right? And so I think it was never more important to spend more time on this first step of you defining the parameters that are actually shaping these things, right? And so that is when this discussion should happen at the very beginning. It doesn't make sense to separate all these functions and so on. The second thing that I think is interesting in your work is that as you are trying different outcomes, you're analyzing different outcomes that the model produces, you regulate, right? And I think that's a very important point, that it needs humans to be able to understand what the model is doing, but also it needs humans to then make decisions to say, no, this is not close enough to the water, or this is not whatever, you know, the decisions that you made, right? And again, I think in the future, it's good to present those things in a way that helps us understand, you know, what actually is the human impact. Because you made a lot of design decisions yourselves by defining those impacts. We are all making decisions by defining the actual underlying logic of these models, right? And so I just think we should spend more time on explaining, you know, what are the underlying intents and, you know, why are we making those decisions.
Yeah, I had the same feeling. I mean, that there's been a lot of system setup and algorithmic setups and gaming setups, and you somehow failed to edit, filter, clarify, to bring it across. So even someone like me who's thinking about this and following this, it's really difficult to follow. And there's some new things which I don't see if we can easily integrate. You know, the prisoner's dilemma kind of diagram. I don't know how you've done with it and what would mean corporate, non-corporate mean. Is it sale or trade, non-trade? There were also some surprises where you compared the LLM fueled, let's say, development process versus the reinforcement learning, and there was nearly kind of 10x advantage in the reinforcement learning, or let's say 7x in terms of the reward system. That these things were kind of staggering. I'm a bit mistrusting, but at some point to go in and say this is how we've kind of calculated value and reward, and then explaining to us how is it, why is that so much more successful. So these are things that I agree about, and I know that there's a lot of intelligence and thinking, and you know, you have fascinating concepts like policy gradient. I mean, this really inspires. You know, I would love to sit with you and the team for 5 hours to get into this, and I think there's a lot. And I do think what is very powerful, which we know for many, many years, you know, but which comes through here, the procedural way of working and developing. You can actually have city scale geometry visualized fly-throughs with a degree of detail and convincingness, and then you also should trust that these decisions are not intuitive, but they're procedurally, and one could start to query the rules. I mean, if you actually go and query the rules, we will find problems with structural logics. And I want to say one more thing, though, but it's still very powerful, and the team in this studio before had used a similarly kind of degree of detailed on a massive scale through modular and module iteration and parametric modules. This is different to some extent. I would say you can say this is a kind of parametric model, the tower. But I do feel a bit like what Claudia was saying. I question a bit the zoning was gone too far, education, production, research, and you have these three worlds which in themselves, each of them becomes a little, they're differentiated, but failing on the edge of being overly homogeneous and repetitive, each zone, and then the zones, so you have three relatively homogeneous zones, and I feel that you should have been more advantage of integrating and blending, generating kind of blend models, and interspersing, having various ways of kind of mixing in with different types of granularity. And you would have had a richer city. So I think each of these cities can, on the edge, as I said, of being overly monotonous. And then having three of them doesn't, I mean, it's overly simplistic. These ABC kind of three sub-centers. Also, you know, sub-centers could you know, these rings and concentric rings could bleed and blend over each other, etc. So that's where I think, on just stepping back and looking at the overall model, I find it too simplistic.
I mean, I just want to say that obviously, you know, it's amazing work, and you have done a lot of really great stuff. I think what we're talking about is stuff that, you know, the next phase that you could actually expand and, you know, go into, you know, later. And just didn't want to sound way too negative.
Yeah, Hi. I mean, first of all, I think it's an amazing amount of work, seriously. And I know you're exhausted and very tired, and it's very tough to be the first team always in a review, but here we go. What I miss is that I see an incredible amount of models, physical models, and I missed the kind of the logic in which these models plug into your reasoning and into your strategy, because I see some, I appreciate the effort of trying to build a large model, trying to make it stand with an exoskeleton, putting the beams and going through the troubles of making it work. But I wonder how this trouble of going through that and through your material prototypes that are on the corner, and this very interesting physical failures or attempts, a kind of feedback into the overall system because it's great work and it's an amount of work that's quite impressive. But I'm repeating myself, but it'll be very interesting to see how this plugs into your reasoning and therefore achieves, I think, more diversity again, going back to Patrick's point. Yeah.
Hi, Marcelina. I'm an architect and urban designer, and quite frankly, recently more of an urban designer. Well done. I mean, it's a great job. I think we are all shocked about the amount of AI you used. I feel old when I look at it. Probably that's the way forward. But what I struggle with is, you know, the way you look at the city is the same way you looked at the buildings. And to me, cities are the negative. They are opposite. You don't really look at a master plan the same way as you see the building. It's not about 3D geometry, it's more about the journey. To me, cities are 5-dimensional. You know, it's the experience, the sequence of spaces, what you experience on the way. They are very linear, and also they work in time. In order to get to the right master plan, you need a lot of analysis, and I think all our colleagues said that already, so I'm not going to repeat it. But you know, just for future, when you do the master plan, think about what the person walking through your streets actually sees, how they experience it, and what they will remember. You know, so to me, this element was a little bit missing, actually.
Can I add something? Yeah, thank you. A lot of work, maybe even too much work. It's so much, and you obviously had a lot of enthusiasm in going through the scales. Probably not enough time. Maybe it would be interesting if another team or yourselves would develop this further in a sense of maybe going. I've appreciated a lot the sort of refinement from that scheme to the final one. You know, how you went to this very in a bit simple allocation of one plot, one building, and this sort of excess of road network that you had there that then got a little bit refined here. I think that would need probably another step in a way. There are the key parameters you used on your primitives. I don't think you explained them maybe enough. There was obviously an element of allocation of input related to real estate, the proximity to the river and so on, but there are a lot of other parameters you could have probably taken into account, which are the wind, especially next to the river, solar exposure, heat gain, all sorts, you know, like environmental parameters that are kind of at the basics of when we design buildings and cities, including also, and I mean, I don't want to sound basic, but the road network, how crossroads works, you know, all of that I think it would be interesting to see this develop further to become more of a real city where people can actually drive a car without crashing into each other, where the amount of roads is reasonable instead of excessive and so on. So I think there's, you know, there's a lot more that could be done, and it's a great achievement in a way in view of the potential that it's got of becoming more refined.
Thank you very much for your presentation. I'm Jim. So I think, yeah, to jump on what's been said already, I think it's super clear on how you really put a lot of energy into the programmatic detail the city, how you manage, your reinforcement learning strategy to really balance the different programs in the city. What I think, to jump on everything that's been said, on what could be the next step is really, zoom out a bit and maybe focus more on what could be the rewards for the resilience of the city, what could be the ecosystemic services that you bring when doing your master plan. When I see all your renders, there are a lot of greens area, and for example, like I was wondering what was the reward you put into your workflow to dispatch these green spaces into your city. Does it bring a quality to the space? Does it actually match an ecosystemic services like water retention in the city, bringing, managing the heat pockets when you start spreading the city. So I think that would be a super interesting next step, is putting the same energy you put into the programmatic detailing more at the master plan level.
Amazing project. Presentation is fantastic with a lot of models, and I can see that you quite enjoyed actually from the master plan to the highly detailed model. I think you just start to show the potential of working with AI. In terms of master plan, I think it's highly complicated than what you actually try to do here. Especially the governance and especially the resident, especially like the land price and construction cost, and there is industry clusters which actually make a highly impact on the site as well. Having said that, still I think you start to explore the bottom-up process, which is quite sort of very unique actually compared to traditional master plan technique. I think probably it's kind of, maybe you don't have to answer it, but I think you probably need to sort of clarify the challenging agenda to figure out the design decision maker, especially the main governance for the master plan. I saw some element about the planners and some element about program, but they are at the moment kind of the beginning stage. And I think if you can add up kind of a couple of more layers on each decision-making the factors, then I think of course they may become more complicated, but somehow they become the more persuasive to the reality world, because you just said that on your introduction, you say you wanted to explore about your pipeline of the master planning, but if you declare that, obviously you have to sort of make it go deeper. What is the real the decision factors for example, like how are you gonna place the buildings around the site? And the beginning of project, I think in this plan, I mean right hand side there's yellow and blue and purples, and then I immediately thought, oh, it's kind of probably done by the predation zoning, which is not the true case, isn't it? So maybe next task for you is kind of you have to sort of diversify all these the element, and then go back to the AI and sort of generate things again. Then it's gonna be much better, and it's gonna be more challenging project for you for this step. Thank you.
Following the comment from the others, I have another small reflection that if you, I don't know, work more on the project, maybe you can take in consideration. I can stop thinking that you devise a mechanism or a sort of workflow which is very sophisticated and interesting for how you're applying, but maybe you should be more critical of how you're applying. And in terms of hybrid, I was talking about hybrid program, but there is another fact that also looking at the rendering, I find quite striking, is the role of landscape or the role of cars in your rendering. If you notice, the car move and the people are static and all the rest is static. And there is a quite large amount of what it looks to be tarmac, which can be your decision or proposal. Probably I will have a totally different one. But I think if you have this sort of proposal, you should have an argument for it. And maybe you could apply your tool to the design of landscape. Because in a way, your city morphologically resembles landscape, but process-wise, elements that are related to landscape and photosynthetic organisms seems to be more little garden that are patched here and there, rather than really having a role in the city, an agency, possibly. So could your tool be applied not only to floor plan, but to other systems? And before I was mentioning programs, but I would say even the landscape part of the city and how you structure it. And then if you end up with a city of car, I'm okay with it. But I would like you to think about it and speculate about it through your tool. Maybe you can even have speculation that are extreme and then decide what it becomes your actualization. Yeah, my last comment. Thank you.
Yeah, I mean, just to reflect on like the things that are coming across to the rest of the jury, I think the strength of the project is also its kind of weakness in a way, right? That the strength being that like you've really investigated like how do you do training, gotten into like you started with your first few slides which said that you like AI doesn't only mean like text to image or text to 3D. Like how do we situate design agency by inspecting things that go far as back as 1980, and start with those simple algorithms and look for ways to incorporate design. In that sense, you've been quite successful, like both on the reinforcement learning and also on the latent space and shape training. And even though it is simplistic right now, related only to 2D plans, in terms of methodology, you have demonstrated, like at least to me, the potential of things like that. Like if you invest effort into training, invest effort into understanding how the training process works, and what it delivers is like this idea of a latent map where it's a universe of all possible maps, all possible plans, and then you can blend them, and it's you know, each cluster can be recognized. They all live in this unified space, like of the brain of the AI, so to speak. And you opened it up sufficiently, I think, like to inspection, which, you know, a large language model, we don't know what's in its head, right? Like we don't know what's in a large image model, like what the latent space looks like. So I think you brought that terminology, you opened up that space. Again, similarly on the game AI, you've explored, opened up terminology and possibility of understanding urban development in a bottom-up process. It is crude for now. It is only a two-player game, and the reward system you have not fully explained. And also the idea that like when does development get stuck? Why does it get stuck? What was the conditions under which, like, you know, one player, like let's say the council, doesn't want to invest anymore in infrastructure? Or what is the other condition where like there's runaway success for the economic developer and so on? So you opened up that possibility, and therefore the weakness is like not explaining that, as Patrick and Jan pointed out. And the second weakness that comes from like this focus on methodology is like the architectural and urban ambition is not coming, it's not been challenged sufficiently, right? Like you've been true to the process, and so that is its merit. Like, you know, this is what you can get by following your process like from start to finish. But like it's also something that you should challenge, like now look back and say critically, like, you know, what kind of urbanism is it delivering, and like what parameters in your methodology do you need to change to deliver better urbanism and better, you know, functional spaces for education, better residential spaces, and you know, that kind of knowledge economy hub. Like so just to say, like, your process is very strong, and you've opened up new possibilities. Like, and this is the first time as a studio we're looking deep into like the technical details of AI. And so in that sense, I commend you, and like frankly, I learned a lot by the way you have explored the topic. But it's also to take on board, like both as a studio and as a team, that like, you know, the results are not yet fully compelling from a design perspective, like from an architectural urban perspective. And I think that's fair criticism. Yeah.
Okay, and since this is the first of many projects, we're going to congratulate. Phase one, can I ask you guys to start helping with the models and take them to the studio? We'll have a second. Guys, you know what we can do? We can bring the models right into the room there, and then you guys can organize it.
Thank you.
Thank you.
Okay, this is better. Yeah.
The cursor is still there.
Maybe I should tell him. Yeah, go on. Yeah. Hello. Hello, we are Team Ember from Studio NGS. I am Sandeep. This is Gal. This is Who. Our studio brief includes designing small minimal space units that can transform, move, and react to extreme climate change situations. This year, the studio brief aspires to get closer to urban environment and act as a system that integrates with the city. Another aspect is building vertical structures that utilizes space in a smart way and able to create three-dimensional unit aggregation. Our project starts with the understanding that climate change affects urban environment is much more common, like droughts, like floodings, and that happens in a different ways. One of them is increasing scenario of wildfires. These are some of the deadliest wildfires in the past century. We also looked at the few recent wildfires and understand its impact on the urban infrastructure and the human lives. Wildfires are affected a lot by environmental conditions in the area they occur. We divided our study on the wildfire components into three main chapters: formation, progression, and the mitigations. In order for fire to form it needs a spark and a fuel plus oxygen, but those conditions alone are not enough to create a large-scale wildfire. The conditions that create a large-scale and fast-paced progression of wildfires are the ones that determine how large it will get. Those are mainly amount of the fuel in the environment and the topographic conditions and the winds. What we mainly understood from our research is that we can't start using our units for fire mitigation once a large-scale wildfire has already taken place. As we saw, when the latest fire took place in the California region, the fire progression of wildfire can be unstoppable in certain environmental conditions. To prevent from spreading, we need to plan to take several steps that will make it harder for it to progress. In correspondence to our project title, Ember, the small particles of fire are considered to be one of the biggest factors that affect the wildfire spreading the pace. If the conditions that the ember particle lands in are good for fire to start, then it will progress. Our goal is to prevent this from happening.
In order to understand how we can prepare our aggregation design for the case of a wildfire, we had to initially understand how a fire is progressing, how each factor is affecting its progression, and how much time it takes to progress in certain conditions that can be situated on our site. To better understand those conditions, we created a simulation that not only gives a tool to understand the real-time fire progression, but also let us plan ahead based on some certain patterns. Pacific Palisades is a large area in Los Angeles region. In January last year, it was hit by major wildfires that spread across around 95 square kilometers. This area is especially vulnerable to wildfires because of several key factors. First, the surrounding topography creates conditions that help fire spread quickly. Second, there are large areas of dense vegetation that provide continuous fuel. And third, strong seasonal winds can rapidly accelerate the speed and direction of the fire. In addition, the site has extensive WI areas where national landscapes are closely connected to residential neighborhoods, increasing the risk on the urban core. From our research, we understood that the areas of WI areas are starting to be very common all around the world, and especially in the US. These areas are much more prone to wildfires because they're closer to nature and usually situated remotely from the main urban infrastructures. At the same time, these areas surrounding the city can also act as a protective layer for urban development. Instead of seeing them not only as a risk, we choose to see them as an opportunity. After that, to create our own strategy, we looked at the different conditions in our site and situated our units according to it. We used the vegetation removal strategies and connected it with the existing road system and to create protection border zone between the city on the wildlands. Our plan is to situate our units in the fringe between the wildland and the urban environments and to cool those areas for the prevention of wildfires, embers, to create the new fires in them. Based on our research and real-time simulations of the fire progression in our site, we designed a master plan for the area that shows the unit location on site and their role in case of wildfire.
We understand that the logistical part of the project is very complex. Therefore, we looked at different clustering logics and designed our own iterations for aggregations that can come together efficiently. From those, we designed our own 3D tessellation, which is based on a triangular grid, which can adapt to different conditions like topography and different porosity ratios. These are based on 3 main units. One is a living unit that accumulates in the living area. The second one is a protecting harvesting unit, which accumulate the infrastructural part of the project, which is used for fire mitigation. And another one for mobile unit, which is used for the logistical part of the project to carry the units into the site, and also used as an escape solution when the fire comes close. The project is mainly divided into 2 main programs and areas. One is the infrastructural part, which is used for fire mitigation and is located in the mountains around Pacific Palisades. The other one is a living area, which is situated closely to the urban environment and is used by the people that operate those infrastructural systems, like firefighters and rangers.
Our strategy for the units distribution on site is based on the regeneration treatment that this area has gone through after last year's large wildfire. We plan to situate our units in the burned areas that can be supposed to be regenerated and to transform those to fill brick areas, which is one of the common strategies in wildfire mitigation. To design our aggregation logic, we went back to our site model and to try to make the aggregation design organized in correspondence to the environment. And then we used the flocking simulation that simulates the flight routes of our mobile units and used the ridge of the topography as attraction points to situate the protecting units, because these areas are usually flat and serve as risk points in fire progression. We then simulated how the mobile units will pick the protecting units and drop them in these strategic points. Then those will come back and join the aggregation that is situated on the perimeters of the urban environment. That helped us to create a complete sequence that visualizes how units will be distributed on site and how will they act in case of a wildfire. The protecting units will deploy water and CO2 that will be used as fuel bricks once the fire is reaching closer, and the mobile units will be used as escape ports that take people into safe zone areas. We also evaluated the effect of the protecting units' actions by comparing the fire progression pace with the use of the units and without them. The results that we witnessed are very good in terms of holding back the fire and giving the escape ports more time to organize and to take people into a safe area.
The next part of our research of wildfire is mitigation strategies. Those includes natural fuel breaks like vegetation removal and the cooling area, and some more artificial ones like mitigation planes. One interesting case study we found in this is the house in Pacific Palisade that managed to survive the last wildfire with no harm due to integrating some systems in the design. For us, the most important aspect of fire mitigation is prevention by cooling a prone risk fire area from embers that will reach it when fire starts. To check this idea, we designed a test bed for our site environment and situated our units in it. We then integrated cooling systems into the unit to check how this can be used to change the temperature. Our experiment was conceived of 3 stages. First trial was integrating the humidifiers in the units, and then designed the different units that would deploy the mist toward the ground from small holes of its arms. Then we captured this experiment with the thermal camera and observed its temperature change. Further, we delimited the unit's roofs and deployed the water in the gaps created, which resulted in a very condensed environment as the vaporized air got cooler, and then the soil, and thereafter the environment. We saw this experiment in the thermal camera, and we saw the temperature drop of 1.5 degree in the span of 15 minutes. These are some of the interesting moments in the experiments. The units that are in charge of cooling the environment are the protecting units. In the order to do that, we understand that spatial systems of water and CO2 harvesting needs to be done. Therefore, we look at the systems that have the ability of absorbing water and CO2 to be used to cool the environment of our site. We also learned that our site enjoys the 20 to 40 days of fog days in a year that can be very productive to harvest around 500 liters per day.
The infrastructure part of the project is located on the mountains around the Pacific Palisades. To accumulate these areas, we use protecting units that are situated on the top of the mountains, on the ridges of them, as those are flat and also more prone to wildfires as the wind accelerates in those areas. The units connect easily as a plug-in system with an external structure. One of the major concerns that comes after the last Pacific Palisades fire is the issue of the reservoir water tanks. Those tanks are usually situated in remote and high areas that are connected to the city with large pipelines and are operating as high water pressure systems for firefighters for fire mitigation. What happened in the last fire is that there was a leak in this main tank of Pacific Palisades, and nobody noticed that. Which led us to think that our units can serve as some sort of a good alternative for this matter, for fire mitigation, as they can be placed remotely and operate autonomously without the need of human factor.
We consider the protecting unit as a packable unit that can be carried by the mobile units and dropped in the site. The mountain area is not always flat, even at the top of the mountains. Therefore, we designed an inflatable external system that can accumulate the height difference and to balance the base units that touch the ground. Once the unit is placed on site, it starts to absorb water and CO2 and deploy it into its full size. To enable this system, we designed its structural core as a flexible joint system that can grow over time. We designed a couple of prototypes to test this idea and used special materials like memory-shaped polymers that can react to high temperatures. The units consist of a mesh that can absorb water and CO2, and in 3 main inflatable water tanks and an uninflatable CO2 cylinder holder. To design the fog water harvesting system, we looked at the way the cacti is working with its spikes and designed our system in the same way with the spike system that can lead each water droplet into the water tanks in the heart of the unit. Once located on the site, these units will have a lot of time to harvest the water and to prepare for the wildfire season when they are full of water and CO2.
The second and main part of the project is a proposal for a community that lives around the city in the wildlands. It's composed of minimal space living units that are used by rangers and firefighters. Those are there not as a technical solution. These are people that see themselves as activists. They want to live closer to the nature and act for the improvement of our ecology. This is also another new idea. We saw a lot of precedents for communities around the world that live together and engage actively in making the environment better. The units are situated as a kind of extension of the urban environment, but they also offer a different kind of way of living closer to nature. The living area is composed of two main clusters. One is more porous and flexible, and the other one is a bit more denser and accumulates more programs. We use connection units that are used for circulation between the units. And the units are used in a lot of different ways, and there's outdoor spaces and connections between them to the ground. The community is not stable. The units can move between times throughout the different seasons, and they aspire to get closer with each other towards the fire-prone season. We tested a lot of different iterations to check how they can be used as a buffer from fire towards the city. So towards the seasons of fire, towards the summer, they're getting closer and closer. Those communities are based on a minimal space living unit. We designed a lot of different iterations, and we evaluated them through different performance criteria, like aerodynamic performance, radiation efficiency, and usable floor plans. Our units are composed of a study that we conduct on the human scale and understood the dimensions that needed for each program for our minimal space unit, which resulted in this geometry. And the unit is composed of different components. It's wrapped with an aluminum skeleton that enables large openings at the three wings of the unit, which gives a much more closer experience to nature. In this section, we can see the different functions of the unit in the different heights, and the central area, which is used as the land spot of the mobile unit. And when it's out, it's used as an internal courtyard. The floor plan shows the different circulation logics of the unit, the entrance points. One other major problem that we occurred is how these units are going to be placed on this complex terrain. For that, we looked at different precedents of structures that are situated in remote and complex areas, and we designed our own kind of microscopic leg that can be transformed and changed and accumulate the height differences. In terms of the interior space, the interior concept is based on a study that we conduct which uses pre-tensioned fabric and 3D prints. Those can be used to create flexible subdivisions in the unit and to enable different programs happening in different times of the day. The unit is composed of 3 different levels. This is happening to get as much volume used as we can. The 3 different wings are used for habitable programs, and some of them are used as double floor areas for bedrooms. These are some interior render shots. The unit is also designed to be prefabricated and assembled on site. We designed it to be able to connect with different pieces that can fit into a cargo ship, and from there being assembled on site with the use of these mobile units. In terms of materiality, we aspire that the unit will be lightweight as possible, so we're using carbon fiber as the main structural system, which is light and both strength. In order to give it durability for fires and for high temperatures, we use ceramic coating.
Our concept for mobility is derived by several factors: logistic access by flying, carrying parts of the units, packing in a small space as a part of aggregation, and enabling escape strategy once a fire starts in this area. We understood that whenever a large-scale wildfire scenario is occurring, we don't want to expose our community to it. So the most important thing to do, design an escape solution for them. To create a migration strategy, we created a distribution master plan that ensures our community stays safe once a fire starts, and throughout these safe zone sites that the unit can be migrated to during in the emergencies. The mobile unit is designed as a part of the living unit. It is planned to be packed in its geometry and used in a day-to-day as a part of the living space, and to deploy with its upper foldable rotors in case needed. We designed the unit to able to carry a total payload of around 1 ton. After understanding standards, we designed our rotors of mobile unit as a foldable ones. The rotor size is 3 meter long and diameter to hold the large weight, and the unit main canopy was designed and optimized to be as light as possible. We designed the panelization system that can be very thin and can be used to harvest solar energy and to reduce the need of large batteries in the unit. Therefore, reducing the weight of unit and enabling it to carry more additional payload.
To conclude our project, we want to express our sense of hope that this important project can make a small change in this increasingly changed world that is shaped by extreme ecological instability. Engaging with these urgent challenges has been both a responsibility and a privilege. The project reflects an exploration of how future architectural practice can expand its role from building objects to shaping responsive systems capable of evolving alongside the world they inhabit. Thank you.
You can explain the model.
These are some of the first iterations we had of how the units are connecting with the application logic of them. These are some initial units that we designed as part of the overall system, the protecting ones and the mobile ones. And this is also a model that we aspire to look at how,
Hi. So these models are used for harvesting and how the units are clustering with each other. This is a site model showing the different strategies that we use over the site. From here we can see different iterations of the living units with the first ones that was here, second ones, and the final geometry and design of the living unit. This mobile unit fits inside this model. This is a model in size 1 to 10. Yeah, we can show that. This is the test bed that we made for the experiment, showing how these units will cool the environment. Here are some of the protecting units designs that aspires to get flexible and packable. Here are some of the experiments that we conducted for the units, the protecting unit harvesting skin that can absorb water. Some of the studies we did for the flexible subdivisions and the initial geometries that we designed in the very few first weeks of the project. Thank you.
I just want to say thank you. I think it's a great project, very well developed. I have little to say other than I really liked it. I think it was very good. I liked, maybe in a way, if I can draw a difference between the previous project and this one. The previous was very open-ended, and I see it more as sort of one step in a way, in the studio research in a longer term. This one was much more self-contained, and because of this, maybe more finite. No, it's more defined and resolved, if you will. One thing that it does say is that when you work with a very specific case study, in this case you had a specific case study of a natural disaster that you could relate to, draw the parameters from, and work around that, gave you a head start in a way, which was a much more defined brief that you could work with. And you did tackle all the problematics of that brief in a very clever way, very thorough, very systematic. I really like the fact that it's very responsive in environmental terms. The water harvesting is obviously very clever. The whole adaptation to the terrain, the deployment. Of course, there is maybe a little bit of an issue of scale, because when you look at your case study and the scale of it and how this specific modular system could tackle with it. You know, there's a bit of a gap of the immensity of the area that has been damaged versus your system maybe, but yeah, other than that is great. Thank you very much.
Yeah, I guess, I mean, I don't want to repeat what Manuela said, but I think it's a great project. Again, a lot of work, really interesting analysis, and really interesting application. Yet, obviously, we're here to see how can we improve the project and be critical. And I think one of the things that I'm lacking is when this unit sit within the I probably miss a little bit of the description, but when these units sit within the terrain, how these units become permanent, whatever that means, right? How they become, how they ground themselves, not just structurally, but urban in its urban dimension, how they ground themselves into the rest of the city and become a kind of an ephemeral part of the city, you know, where people are going to live, they're going to need parks, schools, roads, place to park their bike, and this kind of thing that eventually, you know, starts to kind of grow. And the question, obviously, as a designer, I'm asking is, can this unit variate and integrate these kind of systems, or subsystems, let's call them like that, that will kind of start to grow aside, apart from the unit. I think for me that's an area that will be very interesting to kind of look into, and not just kind of the unit landing into a, let's say, neutral ground, so to speak, right? The other thing I want to say is that it's very difficult to do a large model, and I really appreciate that. I'm the material guy probably here, because it is very difficult to make once you got from that scale of aggregation, which is kind of obviously very geometry-based, computer, you know, grasshopper, you know this better than me. It is kind of interesting, simple, but as you grow to scale, you start to see issues, and I really appreciate the fact that you put people in your thing, you put furniture, because it's really hard. You kind of consider the structure and the thing is holding fairly, with a large degree of integrity. Obviously, the worst part of your model is this thing, because obviously I want to see how it sits on the ground and structurally how it kind of, but I mean, great attempt. To kind of great effort. And it's also nice to see, sorry, I'm extending a little bit myself, but it will also be nice to see the models that are failures. I think it's a bit too neat, it's a bit too clean. I think it's also interesting to see the things that went wrong, just kind of adding to the previous comments on the previous presentation. But in general terms, I'm saying great work and congratulations.
One here, one there.
Yeah, you can pass this one.
Yeah, one, you keep one and we keep one.
Hi, thanks for the presentation. I think there are some lovely models. The unit it's a beautiful model. I like the lattice there, and I love the fog. It's just me. Although I think you could do much more with it. What is its effect on a spatial, architectural level? What is the effect on the landscape around? Sorry, today I'm a bit grumpy, so I pull out all the critical point. But for me, the question is like, if I see your project and I look at this model, I see morphologically they're different from the nearby little houses. But on the other end, do they really treat the landscape or planet Earth in a different manner? They are sheltering the human, but what happened to wildlife and fauna, and what is the environment? The effect of, as far as I know, I'm not an expert, wildfire, they are a consequence of the fact that the forest is not managed, that the temperature is rising. So it's a consequence of the fact that our cities are ignorant, in the literal term of the word, of the landscape that surrounds them or on top of which they sit. So if you, again, maybe continue the project, I would invite you to reflect on not only on how the unit morphologically adapt to the landscape, but how is the landscape responding to the unit? What happened on an experiential level? What it changed? What is the experience of the human and the non-human that inhabit the site? And how is your intervention changing that, creating a new ecology that slowly doesn't need to even move anymore because it's integrated and is taking care locally of processes that have an effect globally. So for me, it will be important, and I will start from this because, yeah, as I said, I love the fog, and I will start into investigating which effect it has, both in terms of living inside of the fog that on the rest of other organisms that inhabit the planet. Thank you.
Well, maybe I misunderstood the project, but from what I see see something that's movable, flexible. So the advantage of that living unit would be that you could live in different place every day, but maybe I'm wrong. So if that's the case, then my accusation to you would be, how do you actually create bespoke unit? You know, how do you give those who live there the feeling of uniqueness? They are all similar, and I'm not sure if I would like to, to live in something like that, to be honest with you. But apart from that, I agree with Manuela. It's very well prepared, thought through. Question, did you talk to technologists? Did you have some engineers' advice on it, or did you just do it? Yeah, so it works, yeah? No, but very well done, great model, interactive. Yeah. Not much more to say. Thank you.
Thank you, and good morning, everybody. I must say I enjoyed the variety of design techniques that you have developed to be able to tackle what is an extremely complex problem. And I congratulate you on your design efforts. After all, this is a kind of a design laboratory presentation. So I think when it comes to looking at all the artifacts, the product of the design effort, there is a lot of skill and a lot of thinking that has gone into it. So I think that is remarkable in itself. When it comes to wildfires, the issue is rather more complex than design. And as you have demonstrated in your presentation, I think it's also visible, although not explicitly said in some of your imagery, when a wildfire breaks, is a little bit like a war zone. And we've seen from the South European wildfires this year and the years before that the fire brigade departments need to employ wartime techniques to be able to tackle these issues. So the point I'm trying to make here is about strategy, and about how you deal with the onslaught, the spread of fire, which is something also quite unpredictable. So in a wartime period, a general may have more predictable techniques than what this chaotic system can lead to. So I guess what I am looking for in these kinds of projects is the type of strategies that one can employ beyond the deployment of pieces, defense pieces, let's say, within these territories. And you had an animation where it's beginning to play now. I think this is extremely interesting here. And I think there is always this kind of attempt to try to resist the spread. But I think there can be a much more intricate defense technique and strategy in the way some of these elements are dealt with, so that we can begin to discuss what other elements of design can come into play to create a much more nuanced, much more kind of orchestrated effort to deal with these things. So I wanted to see if you had thought a little bit about these aspects, what can be things beyond the provision of autonomous sprinkler systems, let's say, and what else can happen here so that there are further steps towards the implementation of real-world solutions to these types of problems. So I'm leaving you with a question. Okay, thanks.
Yeah, thank you very much. It's a beautiful project. I also very much enjoyed the way you worked through the topic. There is a a bunch of. It's always difficult. I mean, I'm really focusing on the next phase or the next steps or the things that I think should get considered. I think just connecting to what you just said, if you have flying elements like the delivery drones, then surely there is some sort of sensor aspect where you scan, and the kind of preventative aspect of preventing fires, I think, is maybe the cheapest version. I know it's not the most popular question, but I do have to think about the cost and the relation from the cost relating to the impact, and I think it makes sense to just be honest about that and just highlight that in the beginning, right? There is, if it's a research study, I think it's good to compare different strategies and see, at what cost they can be realized. And then I also want to connect to the comment that was made before about the scale and just the sheer amount of people that have to relocate into the setting, and just to ground it a tiny bit more in reality, it would be good to just see those numbers, right? Just to know, okay, this is, I don't know how many people to cover that area, but from a design studio perspective, I think it's definitely beautiful work, and it's really enjoyable to see how you work through all the different scales, and yeah, it's very, very well done. Thank you very much.
Maybe I can go. Okay. Thank you very much for this amazing work. A lot has been said already. I have one question: the whole purpose of your units is about, you said it very well, is about mitigation, and the whole strategy about how it deploys on a site is very related to it. I was wondering if you thought about how it could also help restoration. Since mobility is at the heart of your project and that idea of reconfiguration, did you think about how it could respread after a fire to help the landscape to actually regrow and redevelop in a way that maybe it could also help preventing the next ones? There could be so I really see the potential of the way you store water and CO2, though it can be a bit complicated because CO2 scrubbing is very demanding in terms of energy. But you could also see it even as a seed spreader or something. When you think about the grid and the mapping that you could do on a site after a fire, how it could really reconfigure to help that. And I think that would maybe also help defining really the interaction you want between your unit and the nature that's gonna regrow afterwards.
I mean, I think the conversation kind of lends itself to, I think, different interpretations of what you guys have done. I think to go back to maybe some of the points that resonate with me is like, after you do a project like this, where do you kind of take stock of, like, not just an economy of means, but really realistically where the novelty relative to this kind of proposal relies, because there are different paradoxes of trying to hybridize infrastructure and making that, let's say, a space for living. And sometimes those things don't necessarily resolve themselves. So I think as a piece of research, it's important, and especially in your documents and so forth, to kind of speak to your approach, which is very technologically, let's say, forward, but from a point of view that technology will offer the solution space to things, where I think that there is also maybe something to be said of like more vernacular ways of treating the landscape. It seems to me that the project is landscape first. A lot of the things that you guys are picking up on, I think, is very meaningful. For me, the most important thing, and I agree with Jan and Christos's comments about strategy, if you really see it as a piece of infrastructure, then it's not a reactionary system. It's trying to embed a kind of soft infrastructure that can address, I think, a lot of the issues that are around some of these climate related issues, as much about the fact that the soil becomes completely unstable post-fire. We have a lot of friends and colleagues in Los Angeles that had this lived experience and continuously have it. And so I think like the reality of all of this is to try to find a way to bridge a form of technology that's not necessarily just focusing on a very high-performance solution. I think how you guys look at your work and self-evaluate it, the drone part, for me is not a necessary part. It seems to me like a distraction. But the infrastructure and the misting and the soil management and the abilities of thinking about this thing as a very kind of low energy but high impact thing has, I think, a lot of value. And if I was to kind of push you from my own perspective to push it forward, I would see it as an infrastructural implant first and try to really start to use the data. How much water can you extract? How much does it actually influence the immediate kind of climate? You know, on a very kind of local point of view, how many of these things would you need to distribute? How scalable is that? I think that these things would actually bring the project into something that I think is meaningful, but also is not kind of seduced with kind of a conversation about a holistic kind of living environment. Because from the 50s, 60s till now, I think this idea of creating the deployable, the mobile, I think is interesting to some degree, but when it's completely kind of maintained in that, this could be deployed in very different scenarios and still have that same kind of distance to the immediacy of the problem at hand. So I'm very positive of the fact that you took a very complex problem on the table. On the models and so forth, I think the friction that that scenario really has in terms of the bands of how your project performs, I would encourage you guys to kind of take that on board much more explicitly, see where things are really failing, see what the price point would be for something like that, so that you actually believe that this isn't something that just resides in this room, but that you actually see that these things are kind of windows into your near future. Instead of getting a job, you could start to be much more entrepreneurial and think that maybe you have a solution space to some of the problems. So this misting, environmental kind of implants, I feel are where the project is most successful. It may not have the same, let's call it spatial attention that you have made for the living pod and all of these other things, but I feel like this is where you could actually have an important impact, to think of architecture as an infrastructure and to see it as a low energy, low cost kind of distribution into these kind of environments. But congratulations.
Thanks, guys. I think your Ember project sparked an interesting conversation. I think all the comments were very meaningful and very appropriate in the sense that it's a complex topic, to paraphrase also what Theo was saying. And of course, there are not easy solutions. I think what is important and what we can take from this experience is that we need to extend as much as possible potentially what we call architectural intelligence into different realms, and not limiting to the kind of bare architectural problem, but also starting to look at nature as a sort of kind of agent that not only needs to be dealt with, but is part of sort of dialogue, a continuous dialogue. And I think, coming back to the previous comments, I think is important to understand also that whenever we do an intervention like this one, we change nature, no? And we curate it, or we kind of create some issues with it. And so it's important to understand that to solve a big problem like such a large problem like wildfires, I think we need large-scale solutions, no? in a way, and different types of solutions as per the previous comments. And whenever we act and we try to solve this problem, we are going to create new ones. There is no doubt about it. But the issue, I think the important one, is that we need still to try, and we need to essentially try to see if we could find new strategies that are going beyond the status quo, essentially. So there are limitations on the, working with units that potentially are mobile or potentially are more static, potentially are very similar, but also potentially the similarity leads to an economical kind of strategy on making them cheaper and easy to produce and fabricate. At the same time, I think one other comment I would like to say is that the recent events, like of course European wildfires this summer, but also Palisade, but even recently, like in Switzerland, this kind of club or a bar that got practically destroyed, killing more than 40 people. I think this actually tells us that it's very difficult to interact with such a complex agent like fire. No? So in a way, but at the same time, I think we need to try to understand its behavior. It's one of the risks and one of the, in a kind of egoistic way, of course, we are dealing with this risk in the sense that we are trying to save humans, but the question again is also like how we save nature from it. But the complexity of it, I think, requires contributes from different disciplines, and I think our discipline as architects is important in the sense that we could essentially try to have a more holistic approach to it. So the engineering of it, I think, is not enough, and our capability of being inventive and kind of predict the future in a way, in our way, I think is important, and it's useful for the discussion. Thank you.
I'm gonna make it very short. I really wanted to congratulate you, sort of a great work. I am from Korea, so last year we had a very serious wildfire, which lasted almost 2 months. And after 2 months, what we saw was kind of abandoned site. The landscape is all gone. And much worse was, even though you build a building, the home insurance doesn't insure the house at all. So obviously you can't build anything until everything resolved. I don't know what it is though, but so people talk about kind of restorations and regeneration, and in the end of the day, they build apartment to host all the people there. And I think you are quite brave. You start to talk about kind of far away from the traditional architecture, and talk about kind of the mobilized the component, and especially you researched about architecture as infrastructure. And it's very likely, normally, I mean, the people start to, to emphasize on the function and technical issue. I think that might be very difficult for you because the wildfire is very serious business. It can spread within 60 minutes or the 2 minutes on destroying entire villages. Having said that, even though it has a lot of weakness, but I think it is a kind of great starting point between the architect to talk about how we're gonna deal with a natural disaster. And for a long time, it was business for somebody else, engineers and contractors, politicians issue. And I think it's very inspirational, today, and we can share this idea with kind of the new sort of world, which is not really, optimistic in the world. And then we can probably, go further on it. I think that some criticism today is that as you don't, you haven't experimented enough. I think that with this component, you have to talk about how you're gonna deal with the landscape, how you're gonna deal with the community, how you're gonna deal with the real fire. And you can probably, explore kind of different location, not only California, in India or I don't know, Korea and elsewhere. Then, it become more convincing then. So, but it's just cool. So I think you have done a great job, and it will probably, help you to explore for next step. Thank you.
Yeah. Bring it.
You okay with looking everything up? Just
Yeah.
HDMI.
Okay, yeah.
There's a power socket here as well if you need it.
Sure, thank you.
Yeah.
Just randomly select a.
Yeah, thank you. Yeah, I do.
Yeah, I think it's working. Okay. Thank you.
अच्छा जी કર્યું નથી ને
So હું ક્યાં રહી ગયો હું અહીંયાથી કરું તો તું અહીંયા બોલવાનું અહીંયા તમારા બેવનું માઇક
ઓકે
હું અહીંયાથી હેન્ડલ કરું ને અહીંયાથી બોલું both of you speak on this mic I speak on here and I change the slide from this.
हाँ that will I think that will oh you it's difficult for you then you can come over this side okay then I'll move okay just tell me
So down if you come and sit top.
yeah okay, it looks good actually yeah
He said we need to Huh?
let him sit
Okay.
I'm saying chill huh chill
Those are also our models.
Kevin oh
We worked together. He was in my team for a long time. They want to say how to
At least 20 people from India must be watching.
he's also good whoa feels like
Paparazzi. Mobile silent? Huh? Silent. Mobile silent then?
last presentation I thought she's calling it but at this point
And keep having a look at the timer for ourselves. And if we are running late, don't try to push. Just don't tell anything. Just let them see on their own.
well, that is only filling the crowd I think this is
Charging.
બી મારું નાખી દઉં એટલે પછી
Yeah, there's a lot of
Thank you.
Thank you.
Start and pause. It's fine. Start and pause.
Thank you. Thank you. Yeah, sure. Yeah, sure.
Okay, everybody, this is the last one in the morning session. Please.
Good afternoon, everyone. We are Team Tesseract from the Schumacher studio. I am Naman, this is Kevin, and Damek. The brief of the studio is to develop a highly dense and compact mega building measuring 500 by 500 by 500 meters, conceived as a self-standing three-dimensional urban district, effectively a city contained within a single architectural system in London. This project emerges in a context where London is facing increasing pressure from population growth, immigration, and land scarcity, pressures that are being addressed through the proliferation of isolated high-rise developments across the city. Rather than responding to these pressures through hundreds of discrete and disconnected skyscrapers, this project asks whether vertical growth can be consolidated into a single, highly dense and connected mega building. The site sits between the City of London and Canary Wharf. This is a picture of the site that is part of our brief. This project is grounded in Remkula's theory of bigness, which argues that beyond a certain scale, architecture begins to operate differently, where no single system can define the whole, and interior and exterior conditions become fundamentally independent. One of the key contemporary precedents for this project is a Muqab in Riyadh, which proposes over 2 million square meters of floor space, consolidated into a single architecture volume, demonstrating how extreme scale is being used to internalize multiple urban programs within one building. To structure the project, we decomposed the mega building into 4 primary subsystems: program, structure, circulation, and form, and conducted targeted case studies for each to understand how the systems operate independently.
We have divided this presentation in 3 parts. The first part is research. Our first step towards approaching this project was to start researching methods to develop an algorithmic foundation or a framework that governs the essential quantitative and spatial decisions of the building through parameters, upon which we can focus on the design by shaping experiential qualities of the space. So part 1 are the glimpses of the algorithmic explorations that we conducted.
I'll start with program. The mega building accommodates a mix of public, retail, office, residential, and green spaces. As part of the program research, we briefly tested multiple algorithmic approaches for generating programmatic massing, and then focused on a multi-agent system in which program distribution emerges through interaction and global constraints rather than predefined zoning. Here, directional bias assigns preferred orientations to each program, guiding the initial distribution of agents. A vertical bias assigns each program a preferred position along the height of the volume, guiding agent distribution from bottom to top. A macrofield bias introduces large-scale spatial tendencies, shaping how different programs gravitate towards specific zones within the overall volume. Using the multi-agent algorithm, we generated and tested multiple iterations of programmatic distributions before converging on a stable configuration whose underlying logic is explained in the further slides.
Then we scaled down to local scale to develop massing at a local resolution. For this, we considered a proportional semiology for different programs, like cubic proportion for residential, taller one for commercial, and so on. We developed this massing using attractors, influencing light and traffic penetration in a bounding box. So this is a rough sketch of one of the residential local massings developed. This is a massing for commercial, where a unit voxel size taken was 10 by 10 by 20 meters. And here are some rough sketches. These are for public or green, where the unit size is considered at 20 by 20 by 10, and a rough sketch, a rough idea of the same. Coming to the circulation algorithm research, we started the circulation research with an assumption that we will get points or terminals to connect and navigate through once the program system is developed. So we studied and developed different algorithms to make network connections, among which a few main ones were proximity network, minimum spanning tree, Statera tree, and Pfizer-M growth network. So we populated the global cube with tentative terminals to form connections through a network, trying to search for shortest way to connect them together. Here we are showing some networks developed using each respective algorithms in a summarized format. On making analysis of these, we found the Statera tree network to be the shortest amongst these, forming direct connections by adding ferment points, but without making any loop. So we take it forward, and then we also conduct studies to develop a secondary network focusing on more of the qualitative aspect than the quantitative aspect, for which we did some privacy and traffic-related studies. And alongside that, we were also making attempts to translate these networks into architectural spaces. So here were a few attempts. And this is a sketch of a junction formed using one of those attempts of flat Statera tree network concept.
And for the structure, at the scale of the mega building, we realized that stability can't depend on a single system. It has to emerge from a heterogeneous field of logics, integrating optimization, topology-driven analysis, orthogonal, and shelf-based systems. We started with simple proportions trials, how different height spans and support distributions. So we were trying to understand how the structure itself wanted to behave. Here, the domain was then made more complex with aggregations, voids, and offsets, along with strategic supports and combined vertical and lateral loads. We further also experimented with shell structures, testing the shell's performance under structural loading, how curvature could enhance stiffness and redistribute forces. And for the form, so we used Eulerian fluid simulation to generate program-responsive transition zones within the mega building. The Eulerian method was chosen for its ability to produce physical, coherent, and least energy path through a fixed grid field, allowing the flow to navigate complex, non-uniform constraints created by program clusters. The simulation yields a continuous divergence-free vector field computed around programmatic obstacles to form natural and efficient transition zones. As a flow interacts with these zones, it produces a scalar field mapping energy density with high scalar fields. So here's a sketch of that, and this is an example of one of the spaces in the mega building we designed using the fluid simulation. Here, now we began to treat architectural form through the lens of semiology. The program points which are generated using swarm intelligence were connected through peripheral networks. So once the field was set up, we applied a divergence-free 3D vector field, twisting the space without volumetric gain or loss, producing circulation-rich filaments and stable cavities. Onto this space, we layered program-specific fields, attractors, repellers, and curl functions, each inscribing a distinct semiological condition. Finally, we layered attractors, repellers, and then for commercial, we had high curl, residential high attraction, and office with high repulsion forces. These are the different iterations which we tried based on solid void ratio, ATM continuity, daylight access, and commercial loop closure.
Starting from algorithmically generated program points, a guiding volumetric field filters and organizes the point, which is then voxelized into program blocks and locally aggregated to produce a coherent global mass. These diagrams show the individual programmatic voxel clusters and their integration into a single global aggregation based on the distribution logic developed earlier. This is a first global sketch of it on the site.
Once we gathered enough data and methods through our research, we narrowed down applying those algorithms on our context, stepping towards shaping the mega building. Therefore, the second part of our presentation focuses on the contextual and architectural development of our previous researches.
This section focuses on developing the programmatic logic into architectural space. The global mass establishes the initial programmatic condition on which subsequent algorithmic logics are applied. Programmatic points are first aggregated through spatial proximity and voxelized using distance and open face logic. Points are then resampled from the voxel mass and re-aggregated, producing a heterogeneous global mass. A limited set of program anchors is fixed, and surrounding points are assigned through spatial proximity. These point clusters are then voxelized using mid-distance logic, translating abstract relationships into volumetric programmatic masses. After assigning program through spatial proximity at the point level, the resulting clusters are voxelized into discrete programmatic masses. These voxels are then re-aggregated using distance-based logic, enabling a second level of mixing that intensifies heterogeneity within the global mass. The same voxel and open face logic is applied across different programs, while the rules remain constant. Varying thresholds generate distinct spatial behaviors. We have residential concentrated in the west, commercial towards north, green in the center, and public spaces towards south, producing a differentiated yet continuous global mass. This is how a mega building is vertically distributed from public and the ground to residential as we go up. This is a view from Thames.
Let us talk about the development of circulation system. Combining all the previous researches, we organized them in 3 tiers of resolution: global, zonal, and local, where global network means longer travel paths, but lesser and main terminals only. We further divided the network by the height in order to create networks that serve specific zones and have a stable angle. In the tier 1, for example, which is the global network, we use the Statera network developed previously, connecting 62 terminals across the building. These networks are in 4 horizontal layers as discussed, and they are connected, binded vertically by 4 major vertical cores. On the screen are the 4 horizontal Statera network layers, which we considered optimizing by reducing the connection angles, turning them into 4 major high street-like main belts across the building height, which will be more social and natural. Here we explain one of the vertical cores connecting the Statera layers. This is a proposal for the kind of mega-lift cores that we're designing, which can start at the bottom by carrying 1,600 people in each core each time and get shrinking in capacity as it moves upwards. This is our proposal for the 4 vertical circulation cores, where we are using a double-decker lift with a capacity to carry 50 people each at a time. We clustered such 8 lifts, forming 1 shaft, 4 shafts, combining together 1 vertical core out of the 4 in the mega building. So this increases our capacity to carry 1,600 passengers per core and 6,000 passengers roughly throughout the building in one time. This is a tier 2 zonal circulation network, forming a bridge between the global network and the local circulation. This network is kept highly orthogonal, so it also increases the detouring. Tier 3 is the local network connecting zonal terminals to each local entity. Then we prepared a circulation sample route from the start to the end of a local terminal, which shows the distances covered by each tier and the number of junctions in each. Then for the junctions, we also made some attempts to design them. In this, we designed the translation of the circulation network into architecture. So this is junction at the top with a smaller capacity. So as you can see, the networks we had in this, we translated them into architectural space that looks like this. This is one of the mid-capacity junction stations. In order to divide the connections and crowd, we split them into 3 floors connected by a ramp. The design for the junction stations in this, with a capacity of 1,600 people. Here we have also converted the networks into more social and greener belt than just mechanical travelators. So here are a few glimpses of the experience it offers. These are the tier 1 circulation belts, which we discussed earlier, which have more natural and social fabric. And we're showing how we split them in multiple layers. This is a view of how the building communicates with the city. And one more view of the mega building from the Thames.
And for the structure, To solve the orthogonal part of the structure, we started with spatial voxels, generating a 3D grid and occluded voxels to define the permitted structural volume. So we used two algorithms, genetic algorithm and simulated annealing algorithm. Structural lines follow voxel edges only. They never pass through a voxel. A line starts on an edge and keeps going until it either meets another voxel edge or it meets the cantilevering limit. Then it stops or it ties back. So it will check whether the voxel next to it needs to have support or not. So these are a few sketches of the orthogonal structure. This is the hierarchy of structural elements. Every nth level, we add lateral ties to lock the frame and connect to the perimeter system. Split into three, the primary support acts like mega columns that runs through most of the 500 meter. They pick up the majority of gravitational loads and act as the main vertical spine. Secondary supports a shorter column that start and stop on beam levels. For this stage, we focused on structural integration using topology optimization to resolve both peripheral loads and orthogonal loads across the interior. This is the integration of exoskeleton structure with the orthogonal structure at various levels. The closed edge ring beams act as diaphragm cords, connecting the orthogonal system at specific intervals. After the initial topology optimization, we remodeled the structure to translate the optimized geometry into a much more architecturally coherent system. The remodeled form preserves the load trajectories and material efficiency. So this is a view of the building from the riverfront.
About the form development, looking at the vastness of the building, we started exploring design and modeling techniques for quick development. This design technique was oriented towards housing, which we can multiply into clusters using each module. This is an example of a housing cluster we developed using this technique. This is the second design technique, where we simply liquefy the voxel geometry into fluid geometry. And here's an example of the same. Parallelly, this is a view of the mega building in perspective with the Shard and other tall skyscrapers in the city of London. In the part 3 of the presentation, we turned the algorithmically generated aggregations into a refined design, cluster by cluster, chunk by chunk, reflecting upon the theory of bigness, where one single design system cannot dominate the entire building. We introduced the concept of gradient design language from sharp to fluid, breaking the visual monotony of the design. We first start with the fluid design language, which we use for a public plaza. This is one of the public plaza that we designed, overlooking the spectacular skyline of the city of London. This is a public plaza that acts as a spillover for different commercial and residential blocks. And this is a view that shows how it sits with the rest of the geometry. Next is an example of semi-fluid design language for luxury housing. So this is a central commerce facility within the housing cluster, as we were talking about how we are trying to make some heterogeneous programs. Here's an example of a sharp design cluster. We also designed affordable housing using the same sharp design language. This is a render of the same. Next, we go on to how we took these modeling experience into cluster by cluster development. So we take the first cluster, which is located here in the mega building. This is our detailed cluster development. In this space, you can find the offices, residences, public, green, all the spaces together, which is the quality of the mega building. We have also showcased how we amalgamate all three fluid, semi-fluid, and sharp design languages with each other at the same time. So these are the offices in that space, the residential, the green and public spaces, circulation, and so on. One more view showing the same. This is a human level view from within the cluster. Coming to the next cluster, which is the NE Sports Stadium, which sits right at the top of the mega building. This can be a multi-purpose arena with a capacity of a maximum 2,000 people at a time, dedicated for gaming matches and other events like small concerts and so on. Here's an indoor visualization of the same stadium.
So the next cluster we developed was a complete fluid design language. This space is more about hospitality and leisure in nature. So we leveraged the interpreting and overlapping massing that existed to convert it into a multi-layered experience. So here's another view of the plaza. And then here's a view of the leisure space and the hospitality space as well. So, yeah. So here, now we'll have a walkthrough video.
We'd like to show a short walkthrough of our project. There's no sound. No sound. Wait.
So this was the initial exploration in form, and then we had developed a Statera tree network in terms of as a primary circulation network, and then we had this global massing rough model, which this was a Houdini form which we generated, and then we voxelized it further. And this was the initial housing cluster which defines the fluid language which we tried to incorporate. And we had this initial similarity in terms of residential, public, and commercial. How are we visualizing it? And these are the transit nodes, which we tried to define it in the center node. And this is one of the public transit junction which we developed. And this is the mega cluster in which we try to amalgamate 3 different languages and 3 different programs. As you can see, there's public plaza, which is like integrating with the residential, commercial, and leisure activities. And this is where our global mass sits. Like this is a site context, and it's sitting along the themes. And this is the esports arena, which acts as a bridging mass between residential and commercial spaces. And this one this cluster is focused towards more hospitality and leisure activities. Yeah. Thank you.
I think, thank you for the ambition. Obviously, it's a very ambitious project, and as you know, the new Murabba isn't resolved, so it's amazing that you're actually trying to resolve something like that, which is, I think the fact that it's a real challenge, that it's somewhere in the world being challenged by challenging architects is obviously makes it very relevant. I have one comment. I would have thought maybe, when you started defining the parameters that inform the position of the voxels within your mega grid, I would have thought that maybe you wanted to incorporate, those are really the key issues when you design super deep buildings, which are daylight, natural ventilation, and emergency escapes. I think that would have probably helped clarifying the way you talk about the brief a little bit more, because clearly, once you start incorporating green residential, you need to count into a certain amount of daylight, and as we know by regulations, and natural ventilation, unless you want this project to become very intensive in terms of energy consumption. So, when I saw your, for instance, particle animations, I thought that this is what you wanted to portray, to kind of regulate the amount of daylight and ventilation that each voxel would receive within the positioning on the grid. So maybe I would think this should be probably, I would imagine, the next step to make it become more real. I mean, it's a very complicated project, and you got to the point of defining the number of lifts. So, I congratulate you for that, but I think, yeah, maybe there are other things that now you should go back and look at. Anybody else?
I can go. I don't know. I mean, first of all, congratulations on creativity. There's lots going on, and it's beautifully presented. I also note you introduced music, which is great. Beautiful. I must say, first of all, well done for sorting out the structure. I was also released to see that there is some sunlight inside of the building. It's actually quite fragmented, so it is clever. It has a lot of variety. It has many spaces. What I think is missing, though, is the nature. Is the fact that if I was to live there, I would probably be scared to live there. So I would like to see this environment as a little bit softer. But that's something you can work on in future. I must say I would really like something like that to happen in London, because that would really put us on the global map. Having said that, that's the challenge, because this building will become London's landmark and symbol of the city. So yeah, lots of work needs to be done, but good start, I think.
Thank you.
Hi, thanks for the presentation. I like the challenge, the morphology, most of them, and the hybrid program. I'm a bit confused by this model, I have to say, on multiple levels. On a level, I don't know if the 3D print didn't come out properly or what's the problem, but I think maybe this is not the best iteration of your morphology, and I'm wondering how you selected it, because there are these huge slab and leaning situations which are morphologically a little bit strange. On the other end, this model confused me a bit. The main point, in the relationship that established between the City of London and your proposal. How do you relate the current morphology, granularity, landscape, which seems to be portrayed as very neat in this model, with your proposal? I think the rendering are better in that sense, because I don't know if what you envision, but the rendering and the video is slightly gloomy. Cleverly, you come from the water, so one might think that London might be flooded or not. But you might reflect on the fact that water may rise and there might be the need for infrastructure of this kind, and that, I don't know, that in terms of structural point might need very, very large piling to support, and so in that case quite a disruption of the soil below. So if you want to go to this effort, I think you need to find a trigger for it as well. A landmark, I'm not in favor of landmark, sorry, because I like distributed system, but a landmark becomes an advantage, but can also be a very bad marketing stunt if not appropriate. So what is the scenario? And usually I'm not in favor of this topic scenario, but it's a fact that water is rising. So maybe there is something there that would allow your project to sit more comfortably in the context, and in a context that is maybe not as neat as the model portrayed. Thank you.
Thank you very much for your presentation. I really like the radicality of your approach, and starting with that voxel basis, let's say. I'm thinking out loud, but I was thinking about the potential and where it could really reach, because I really see this version as one possible version of many. You said it yourself, like you took bias from the beginning that could actually become variable if you think about adapting to many sites. So I really see it as an exercise and basically building a model for generating a city within a constrained volume. And that's where I see the interest of your approach. Still thinking out loud, the way you thought about, parsing the structure from the flow, the circulation, all that, makes me really think of the current AI trend about agentic systems that could maybe be interesting to look out for if you think about different agents working on the structure, on the circulation, all of this. But instead of having maybe like the bottom-up approach that you followed, having agents that can actually collaborate together, and then your system would be able to maybe generate cities based on external parameters that would be the context, the initial context, the existing circulation, and how you want to fit that constrained volume city into an existing framework, let's say. So thank you again.
Thank you so much. It's obviously very impressive. I suppose my question is around, I'd love to know how many people live here. How many people live in your mega block?
So we had a GFA calculation roughly of around 2 to 3 lakh people not living but visiting the structure village.
But how many people live there? 200,000. Okay, so it's a small city. It's not just a city district, it's a small city. And I think it probably generates its own weather, let alone its own nature. And as the next stage emerges, I like this idea that it has a moment of transformation. And maybe that is to do with nature and weather, and a kind of decay and change over time, because you've gone through a tremendous effort and put a tremendous amount of detail into a huge variety of different typologies of living. And maybe perhaps that's kind of more than the idea can cope with, because when you get into the kind of stylization of a kind of architectural form, when actually what you're trying to describe is a kind of infinite complexity at a huge scale. So perhaps it's about the change over time. It's about the way in which these spaces start to reject the highly specific calculations you've made about the different distribution of program. Because then ultimately you have something that is operating as a city in 4 dimensions rather than just sort of 2, in terms of the plan. And that becomes super interesting. But yeah, I think maybe in the little bits I caught of the last project, the introduction of natural phenomena of the hurricane winds that are about to hit Wales right now, of the spectacular shifts in scale that might occur, the potential for decay, the potential for water rising, I find super interesting because you're actually introducing something that doesn't really have a precedent, and therefore there's a great deal of open-endedness. I think there's some questions to be answered around how you determine bias. How this doesn't become a kind of extraordinary version of a garden city with the distribution of program, and how you actually start to contend with the way in which people live. The idea that I can move up a lift or a lift system with another 1,599 people is kind of shocking. I mean, it's a motorway of pedestrians. So what is that like? It's a whole different world. So I think that there's many, many questions that have been posed by the problem. It's a very, very ambitious piece of work. You've developed a huge amount in a relatively short period of time, so congratulations.
My turn? Okay, hi. I'm thinking where to grab this project from. But there is some sort of history to these types of projects. I think with Theo, we've done something for Famagusta No Man's Land, trying to solve problems of derelict cities within cubes that are super densified pieces to try to compare basically what is a kind of a normal horizontal city versus one of these super dense cubes, and at which point does a city become, enough fit for a project like this. Then later on, obviously, the Saudis have gone quite crazy with these types of projects. And the reason I'm starting from this point of view is because I think these projects present contemporary models of the confusion of the contemporary system, where you have a kind of a late development of a capitalist society trying to bring all the diversity together. And you're in this precipice of things falling apart while trying to keep them together. And I think these types of models are very expressive of this situation in a very even subliminal way. So I guess the point with megastructures is that we are in some positive way testing our ability to manage complexity. And, the obvious question is why this type of complexity versus other ones, which could allow for other types of ecosystems to go through it. So there's always an inherent problem of self-referentialism in these types of projects that one has to be very careful of. It's about a very kind of a limited set of elements coming together. So the first question is, what is this for? What is it meant to do? And to the degree that you guys have managed to bring these different types of systems in relative proximity, I think obviously it's an achievement, having global versus local transportation system structure, etc. But it's only the tip of the iceberg of what you have to do to try to resolve these degrees of complexity. What sort of lies as an unsaid quantity in your model is obviously a certain sense of lack of gravity that you need to be able to move around these spaces. There are areas of this building where I don't know how you would go from point A to point B. So maybe this is a space station rather than something that's sitting in the middle of London. For example, maybe it's a more feasible sort of approach. But I guess the inherent issue here is rather than forcing everything together, and trying to create moments of identification of different components of the system, why and what is it meant to actually resolve remains a bit of a question for me. On all these projects, not only yours, on all the projects that we have seen of this scale. So I think that's the kind of fundamental unresolved question in these types of projects, whichever take you take, whether you work with density, whether you work with sustainability, quote unquote, with sort of real estate conditions, etc. I don't want to take too much longer to discuss this, but I think the issue of scale, and you referenced REM in the beginning as this container of promiscuous activity, is an issue, because I think we're reaching levels here where the scale or the density of human populations come together becomes increasingly difficult to manage in real humane terms beyond certain scales. And I think, if anything, these structures must find ways to resolve how to deal with large populations, okay, in a meaningful way. So I think that's my question, and that's where I might come back to it a little bit later, but I think this is a question that I would pose.
Just a few points. So, the purpose of this, it's located between the City of London and Canary Wharf, and Canary Wharf, City of London is, of course, this exception where you have the true desire of the densified co-location synergy city coming through, because we have a special political accident of history, the old constitution of the City of London, which allows for that. And that's where you see what would want to happen. And then we have, Thatcher opening up Dockland Development Corporation and does something on the other side. So this is trying to compete with these two models and be more mixed use, more dense. Other precedents for me is the walled city of Kowloon. Let's say where the brakes are taken off, the political brakes are taken off, what emerges, and this kind of hyperdensity. And the other thing is for me things like, yes, OMAs, it's like a little architectural diagram that you have this three-dimensionality of juxtapositions and creation. And from our own perspective, my personal fascination with these mega atria buildings of Portman and these complexes, and if you go to the Marriott in New York, and we've tried to build on that. So these are other precedences for me, which come together here. So, and what I find works for me, and as a concept, and basically in terms of Saudi projects, it's more the line, because when it comes to the line and segments of this, the way they're farming it out to multiple subsidiary competitions. We've seen these competition briefs. This is a three-dimensional master plan, where we're getting a brief where you have to design a kind of performing arts complex somewhere between 200 and 250 meter, and there's lots. So these were the inspirations, let's say, for this. And I congratulate you. It comes through for me themes like the richity, variety, the juxtapositions, the richness, and having everything in view simultaneously. In some of these vistas, you're seeing about 150 destinations that could interest you. And when you see it in a city, you can see what's going on, and you're attracted, and you see the events pulsing through. And it is this kind of visibility, intervisibility, communication potential of coming, and then the adjacencies are just above, below, all around in multiple layers. This is less compact than some of the other models. Maybe you've hollowed a two out, but if you stand at Tate Modern and you look at the City of London, it fuses into one kind of massive block, and it has lots of ingredients, but there's only one surface which connects to this, and that's why I think it's fallacious. So you talked about, literally, we have at the moment hundreds of towers in planning in London, which are distributed and disconnected, and they're all these one-way cul-de-sacs. I think there were several hundred towers at the moment under planning, and we have 2 stuck in planning. And that's what this competes with and substitutes for.
I really very much enjoy the research question, and I do enjoy the first part of your analysis. I think all the topics that you highlighted are really crucial. The two aspects maybe I want to focus on. One is time. So building something for 200,000 people will take some time. And so a strategy for phasing that takes into account that over that time things change, a lot of things change, would be interesting. The other opportunity, I think, is what you're designing is like an empty shelf. So to turn it around, go away from the actual shape of the voxels or the architectural shape, and design. When you started showing that in the first diagrams, you're designing an empty shelf. You're designing the public infrastructure. You're designing the skeleton, if you like, where life happens in the city. And I think that goes hand in hand with the public space and all of that. And then over that time, city happens accidentally or definitely not something that we can plan today, to reach that end state. So I think you made that clear in your simulation that this is obviously one of many, many different options this can express itself. But so time is one, and the other one I can't help because I had those discussions with all those crazy clients. From a pure construction point of view, and a real estate logic and a money point of view, just for fun, calculate how much a square meter costs. And there's a reason why these buildings are this high. Because there's a point around, whatever, 200 meters, you can argue, right, where it just gets exponentially more expensive. And so, I know this is not the topic of but I mean, in the next iteration, right, I think one has to have a clear answer for that, because real estate is already expensive, but this is kind of beyond anything. The reason why the line is not happening is mainly a financial reason, that it was just too expensive to provide.
In the center of the line will work.
And yeah, it's really interesting. I mean, do the calculations, I think, is my and then the environmental impact and whatever. But there is I think it's interesting. It's an interesting challenge because there is a need to densify. There is a need to concentrate. But we have to answer all these questions that I think you alluded to. That it has to be productive in a sense, that it actually contributes and it just doesn't extract. If we manage to bridge those schisms or these problems that we face, then by all means, let's try and find ways to build more dense and more compact and more efficient and more regenerative all at the same time. But it's the first one, right, of that. So I think it's a great topic. I think there's a lot to unpack, and I'm looking forward for the future iterations of this topic.
I mean, if I could just maybe, sorry, I need the microphone. I mean, I think it's interesting to understand that urbanism always has these kind of like cyclical waves. There was a moment where everybody consolidated into the city, and then there was the escape of the city, there was the discourse of the megastructure, and usually this kind of oscillates within some form of utopia or dystopia. And the arguments of that stuff, I think, has had a long-standing history. And I think it's interesting to see that some of these challenges that are being posed by clients and people that are trying to basically almost create an instant city, what that actually puts in terms of a pressure, not just on the everyday or the logistics, but I think there's not much work really being done to understand, maybe not so the why, but how. So for example, like we had a colleague here not too long ago who is in Los Angeles now, and he proposed a project called Planet City. His argument would be that we could give over the planet and consolidate all of the population into one dense urban environment. He speaks about it from a speculative futures kind of perspective, and Liam in that sense is not really constructing a real project, but he's constructing an argument, I think, that positions a plausibility of actually addressing complex problems by understanding that it's not just about one argument. It's really about trying to find complexity between all of these different kind of competing things. So some of the comments are speaking about environmental impacts, some of them financial, some of them social, some of them cultural. But I think the reality is, like, we cannot choose the ones that we want to align ourselves with. All of these things, I think, for it to be something that really takes on the spirit, not just of a vision, like in a radical architecture point of view, but in a meaningful kind of competing way, starts to speak about architecture in a different way. I think one of the things that I would say is an opportunity for you guys is to look at your architecture now as something that's lived. I don't think 200,000 people are living here. Maybe it's 2.5 million. The reason I'm saying that is that it seems like then that would only be villas in the sky. You know, you would be making an argument about living that's maybe not necessarily the one that we look at. Maybe we wouldn't privilege the stadium, like let's say Neom does, like a big stadium on the top of a large urbanism. So I'm just saying that the terms of engagement would be very different. The idea of how nature is integrated, maybe it's not just about if we feel safe, but how are all the other aspects of infrastructure embedded in the way that we see this thing holistically? Like, where does food production come from? If we have all of this consolidation of things, it's energy, it's this, it's that, it can be so many different issues. I think what's, commendable of the team is that you're struggling with scale, and you're struggling with actually just introducing normative ideas of structure, circulation, and the impacts of what that actually has in a building this big. But this isn't really a building. So when Patrick says mega building, like the same way it was mega structure, and all of these things, language somehow obscures, I think, the real kind of need to actually see this as not only a conceptual project, but really something that demands a radically different way of thinking. I don't think that we should just look at it on the terms that we have today. I mean, when Claudia was mentioning that you're approaching it from the water, and so it has implications of a different kind of idea of life, the reality of those things is that we like it or not, uncertainty, latency is our new norm. So the question is, like, what is that life? How are you guys, in some sense, structuring that? And it's not about marketing a project. It's really about trying to understand how these kind of projects, if they are realized, could actually offer something different. The reason the line is kind of interesting, in the 70s, Alan Bootwell did the same project. He decided that he would go from the East Coast to the West Coast of the States in one continuous urban project and consolidate all of the city into that. You know, Tom Main doesn't talk about that too much, but that was a precursor for a series of different kind of radical projects. The difference is that that project was an illustration of a concept, and now that there is a certain reality around these things, that just necessitates, I think, us working on it in a way that is more research-led than kind of pitching proposition. Because I think that it's at the time where we actually have to see what kind of options are on the table for what kind of futures that obviously we're in the business of actually trying to get a better grasp of. And I think that that means what it means to have public. What does the public actually do here? How are we dealing with things that challenge normative control systems? Because in a vertical building like this, you know, just lifts and all of that other stuff challenges the way that we actually really think that people are going to be living. And we should actually feel a little bit of that burden. So I think with this kind of thing now, it's really interesting for you guys to just put on the table different kinds of thought experiments that you can kind of really challenge yourself to really speak to. I think that that would make it less about a big building in London. And I think it would really try to bring maybe new subjects in the field of actually how we're actually working on some of these problems. These are prototypes in some ways that can really actually allow us to critically engage in some of these discussions. But I do think that this project demands a different theory. I don't think that REM's bigness really is enough at all. And I don't think it speaks to I think a lot of the issues that I think, you know, people deserve better, so it can't just be about big. It can't just be about more, it can't just be about density, so it has to really start to articulate, I think, also a new language that somehow is in support of these kind of models being something that needs a form of critical investigation. But I think by putting the projects on the table, by working on through them, by having these conversations, I think it allows you to have some moment of self-reflection, and I think that that's something that we all can appreciate. Unless there's some urgent kind of things, I would like to invite our critics who are working very hard with all of the different subjects on the table for a quick lunch. We are running fashionably late, to say it. So we'll try to pick up after in a half hour and sort of continue on the day. And we have Claudia who's giving us a keynote tonight at 6:30. So we'll invite everybody to reconvene in a half hour if that's okay. Thanks so much. Thanks, team.
Thank you.
Shreya.
I'm Yash.
So today we're going to present the Angus studio. We're Team Statera. This year, the studio moves beyond static and extractive architectural models, exploring integrated systems that negotiate human habitation and planetary processes. We reimagine urbanism as a fluid, regenerative organism that supports post-disaster recovery, enables multiple nodes of inhabitation to build a resilient, community-based system for an uncertain planetary future.
The project unfolds through 8 interconnected chapters. Planetary processes are the large-scale systems that shape Earth's surface and atmosphere, climate, oceans, atmosphere, and geological activity. Among them, seismic forces demand an activist architecture that shifts from producing form to protecting and empowering communities. We start by understanding seismic resilience. Passive resilience uses geometry, materials, and systems to naturally withstand earthquakes, while active resilience relies on dynamic mechanisms that adjust in real time. Our project combines both, using polyhedral, origami-like structures with pneumatic systems that not only resist collapse, but adapt and sustain life during seismic events. Our research focuses on architecture becoming an activist tool that challenges fixed infrastructures and fosters regenerative, interdependent settlements in seismic territories. It enables resource sharing, habitation continuity, and rapid adaptability before, during, and after earthquakes.
Rising seismic risk linked to climate change pose major threats to coastal megacities like Istanbul, Tokyo, and Los Angeles, which lie along critical subduction zones where tectonic plates interact through complex and often unpredictable seismic cycles, and where 40% of the population already resides.
We choose to focus on seismic environments, recognizing that architecture is inherently linked to tectonic forces and the geological dynamics that shape the Earth, such as earthquakes.
We studied different seismic risks per region, such as building under risk, fatalities, and economical losses due to global seismic events. Turkey lies on 3 different plates, so we're choosing Turkey as a pilot area, where the South and the Northern Anatolian Faults and the Dead Sea Fault, causing the country to experience many earthquakes per year.
We also mapped the earthquakes Turkey has experienced since 1990s according to the magnitude to recognize how much under risk it actually is.
This was the last major earthquake that Turkey experienced in 2023, which claimed almost 50,000 lives, bringing a new urgency to its biggest city.
Home to 15 million people, it sits on the North Anatolian fault line, and experts predict it's due its own major earthquake before 2030. After the first earthquake, another hit in continuity, which actually led to more fatalities since people returned to their already damaged homes without the knowledge that another may strike. Around 70% of the city's buildings were built before the rule changes that enforced stricter construction standards in 1990, and thus are considered potentially unsafe. With over 200 aftershocks, the Mirage earthquake exposed disaster not only as an instant, but as a prolonged spatial and infrastructural crisis. Despite 2 years having passed since the Turkey's 23 earthquake, nearly 6.5 million people have still been living in container cities across 11 affected provinces. About 70% of the buildings in Adıyaman city were destroyed or damaged, and the scarcity of safe properties means rents have soared up. Meanwhile, the containers may not be available to them beyond another 18 months or so.
Meanwhile, there is little sense of community in the container village, so we went to the site itself, where the cramped spaces are not conducive to visitors, and people generally prefer to keep to themselves.
And thus, our project aims to address this situation in all phases of an earthquake. Pre-earthquake, our units would be situated in an urban edge with minimal infrastructure. During earthquake, the aggregation would work with pneumatic shock absorption and modular deployment systems. Immediately after an earthquake, the collective would come together to form a community fostering resilience and to address post-disaster recovery and displacement. Post-earthquake, the project would deal with temporary permanence, that units would sustain life and foster community, and later, once the need has disappeared, they would be easily packed and redeployed to newer sites when the need arises.
Therefore, we started by looking into potential sites. Since Istanbul is waiting for a major earthquake, we wanted to take it as our pilot area. Here we can see the map of Istanbul with the Bosphorus Sea crossing the 2 continents.
Some of our analysis included population density, building footprint, planned and unplanned residential areas, and urban density. As already stated, one of our strategies, apart from using the urban fabric as a site, is also to utilize the urban edge as a potential gathering spaces. Since we are situating ourselves amid earthquakes, we also studied the earthquake hazard, the ground structure stability, and soil vulnerability.
This map shows the different gathering areas marked in yellow with their building footprint density, showing that the urban fabric is too dense with less free spaces, and for some of them has been constructed upon.
This is another strategical approach as a potential gathering site for small but densely populated quarters for a safe gathering site other than our urban edge strategy. And thus we come to our unit design. Earthquakes themselves do not cause fatalities, rather it is the collapse of buildings and infrastructures that result in loss of life.
Developing flexible and reconfigurable shelters offers a resilient architectural response, sustaining life during seismic events and ensuring continuity in their aftermath. We started by exploring basic polyhedral through their packing logic and nesting qualities.
By nesting and understanding the face connections to pack, we developed an adaptive component to form the basis of our initial unit.
As part of our design processes, we explored a variety of geometrical configurations, testing their potential for structure, adaptability, and inhabitable space by parameterizing various factors.
We also tested the geometrical shapes for transformational qualities to address issues like center of gravity to have a more stable unit design that could morph and adapt. We explored it by studying how the unit could transform and metamorphosize, testing its potential to adapt and evolve beyond a static geometry into a flexible architectural system.
Later on, we wanted to improve the geometry to find out more potentials where we implemented new parameters for new variables such as the legs, the number of legs, the height and width of the base.
Arriving at a family of the original prototype. We were able to critically reflect that the design of our latest geometry was not enabling us to neither connect between units or aggregate vertically for dense urban areas.
And we were able to recognize that the individuality was stronger than a collective logic, which did not address our issue of urban density in seismically vulnerable terrains.
Therefore, we focused on our main design drivers that are urban density in seismic environment, the collective logic, the active-passive seismic resilience, and the ease of logistics. So, coming to the collective logic, we understand that the aggregation, adaptability, and shared agency architecture can shift from a static object to a responsive and regenerative system. Our studies including understanding the Penrose diagram and the quasi-hedral logic to form a better collective knowledge, which led us to go back to our basic polyhedral aggregation, implementing our rule-based aggregation studies that helped us to understand the importance of combining structural and adaptable qualities in real 3D way, revealing how the collective elements depend on each other and not an individual forming a tiling pattern.
These are some other rule-based aggregation that we formed with these quasi-hedrals. Then we're coming to the collective packing logic. We started to look into our original geometry to refine it by taking the same footprint and removing the triangularity to have more adaptable configurations. Similarly, the Penrose diagram inspired us to take a different approach in developing the 3D organization of the units. We were able to form a collective with this through tiling and stacking system. We also tested this aggregation on a shake bed and could see that although the top floors shake, they were able to mitigate shock and dissipate energy through interlocking.
The interlocking was the first step into our vertical approach.
We recognized that the collective logic was still working in a 2.5D and was simply tiling, leaving large voids, which didn't align with our strategy of creating a dense but porous, resilient urban fabric.
Leading us to go back to our polyhedras and begin the process of reverse nesting, we re-implemented the unit back into the polyhedral and tilted the faces to fit inside. Here we show how the reverse nesting is working and the creation of our habitable units.
After the individual, we come to the collective. While reverse nesting, we realize that we require a secondary polyhedral for aggregation, a three-dimensional aggregation. Here we show the connection with the habitable unit to the secondary polyhedral.
Since we had our habitable unit, we connected the second polyhedral to nest it for a secondary unit for a 3D aggregation.
After nesting, we tried to form an aggregation which revealed that there are connections that we were having some gaps, and not all habitable units connect, leading to a structural failure.
To solve this issue, we ended up creating a quasi-polyhedral by rotating, twisting, and merging the polyhedrals and created our own habitable units.
Thus came the formation of the quasi-polyhedra with the nested habitable units.
And by doing this, we then started with the seismic resilience with our unit ground interface. Air dungeon system is a practice developed in Japan where special air chambers that have sensors to detect the shaking of the ground. When a quake hits the chamber, inflate, lifting up the house by 3 to 5 centimeters to avoid the worst of the shaking and lowering the house when the quake finally quiets down.
Therefore, we started by experimenting with pneumatic and inflation.
We tested the pneumatics by single layering and multiple layers to have different results and applications.
We wanted
to negotiate the ground interface by dynamically having the pneumatics inflating in areas to stabilize the unit with the shaking ground. These are some of our inflation tests to have on the base of the unit to lift it up.
We implemented this system to our new habitable units that would have the accelerometer, the sensor that detects the changing angle and thus inflates the airbags to negotiate the ground and stabilize the units.
We also tested the accelerometer by connecting it with our processing so that we could see that the angle was changing, and we could experiment more with our units inside so that when these sensors detect the shaking, the air chambers can blow. We also looked into tensility, which is a lightweight structural concept, and this enabled us to understand the air chambers better because the air chambers would need to lift up heavy loads with, which are the whole aggregation, and therefore the lightness of the tensility system interested us. Here we show the testing of the unit.
The different materials where we wanted to use actually air. And here are the different tests that we have done with sand and without sand on the base isolation.
We also tested it for the weight, where we inflate the base to see how much of a load it can take, and even these small prototypes were able to take like 1.25 kg of weights. So after this, we also tested a physical test with our unit on a shaking ground. We also digitally simulated the airbags to see the simulation and the behavior of the airbags. This was how we were taking the simulation to take place, that the earthquake is detected, the earthquake sensors detect them, air is pushed in, unit levitates, and unit returns to the position once the quake has quietened down. This is another simulation that we were able to simulate that the airbags are lifting up the units, which combines the air dungeon type of a system along with the tensility that would need to lift up heavy loads. After this, we also looked into soft joints.
So we started with the digital simulation, and with the first, no anchor to see that the unit do not have the active connections and don't rely on each other to support, and later on it was anchored it to simulate the behavior and depend on each other to have a collective logic. We also simulate the earthquake digital simulation to test more of our aggregation with different magnitudes and earthquake to see the behavior of resilience and the collective logic.
Here is a simulation of a 7.9 magnitude of an earthquake where we saw that the units can mitigate the forces and dissipate energy to its closed, packed logic, and all faces connecting to each other.
The joint, we also looked into the other soft joints. The joints are flexible and two-directional, and while the rigid ones don't work. So these were our initial tests we were doing with bidirectional joints and compression joints, which actually led to more studies that are these soft joints that we wanted to have between the units itself, because we could see in our digital test that the units themselves, if they would shake, they would be very rigid and would not dissipate energy. To dissipate the energy, we would require these soft connections between the unit, which also help to adapt to the terrain.
After developing the soft joint, we tested it digitally to simulate the behavior to adapt to the terrain and see the soft mechanism of the joints. This is another exercises that we have done where we wanted to test different origamic foldings.
Which actually led to the making of the joints that we actually had between the living units and the secondary units.
Coming to the urban strategy, while working on the collective, we also realized that the aggregate forms larger triangles, pyramids, leading to the nodal points, where the habitable units that were connected from structural voids and can be removed to create interstitial spaces. Those are some interstitial voids with the circulation all around the ground floor. This is a section showing the interstitial spaces with the multifunctional units that are also implemented, the ones that we are calling the second quasihedral that we implemented to have our three-dimensionality in our aggregation.
This is actually the formation. Here we wanted to show that the collective logic, the collective is stronger than the individual because the individuals don't depend on each other unless the collective has come together. And that the community is formed in an interconnected, interdependent, adaptable. We also wanted to structurally analyze the aggregate by considering the central lines of the unit, habitable and secondary as beams, and their vertical connections as supports, while secondary units also form a lines as bracing, which potentially transfers the load and the stress, quantitatively showing that the collective is stronger than the individual. So these are the forces that we would need to mitigate during an earthquake. That would be the lateral forces. And we were able to apply these forces to all the points where we applied gravity, earthquake acceleration, which is the peak acceleration, generally used as 0.3 for Turkey specifically. We could also use 3.4. And these are applied in both X and Y directions. So this is a simulation of the deformation of strength and stress ratio, where we can see that all the points remain at their places. Only the secondary units have slight deformation that is also due to the making of them.
After forming the collective, we also performed a sun radiation analysis to analyze how we might need to remove certain units for better light penetration, as well as describing which faces would potentially have the solar panels for self-sufficiency and energy production.
We also have this urban strategy where we would be aggregating along the urban edge, and also while the, as stated before, post-disaster, we would be having more units in the urban fabric as well as the urban edge. This is one of the renders for our aggregation.
This is the interstitial space that got created by removing one of the living unit that was on the floor.
This is another physical model that we did, and we could see how the corridors were formed, what were the spaces, and how the...
It's leading us to the circulation.
So for circulation, we decided that we also wanted to show how the secondary unit is actually connecting to the living units. One secondary unit connects to 6 living units.
The idea of using this multifunctional unit was also to use it as a circulation unit. But then we saw that this was only functioning between 2 floors, which...
So after this, we had to implement, we also looked at since it's a vulnerable terrain, we would also need to look at the escape routes. So for that, we formed the escape route areas. For high-risk areas, we would need we would need circulation along 25 meters, and for a normal risk area, we would need 45 meters.
So here, the idea was actually to implement a circulation unit as well, which we are taking the volume of 2 living units coming together, where we were placing those ones into the edges to have those escape routes.
So this is the the smallest aggregation possible that we would need to support all the points, and these are the aggregation points that these are the circulation points that we would require, and how the vertical and the horizontal circulation would work. To better understand it, we have this circulation diagram where we show the first floor, the horizontal in the red, and how the circulation units are coming. And then we see the secondary units coming in between, how the horizontal circulation units are working. The secondary units lead to the living units, and then the second floor of the secondary units come in, which are serving as multifunctional units.
So by using these 2 different units, we were able to reach the peakest point of the aggregation. Those are some programs that we are implementing to our units, where we're going to have, as we said, the circulation and the communal units, the vertical farming units, the communal kitchens, upper living units, multifunctional units.
This is the second floor of the same aggregation, where we have these similar functions. And this is the section for to better understand what kind of functions we're talking about. Since the secondary units were actually enabling vertical circulation, but they were the second floor of the secondary units were actually not really used without anything. So we implemented the different multifunctions like vertical farming, multifunctional spaces, or communal kitchens, healthcare units that would be required other than the living units in a community that is formed. So coming to the structural system, our structural system is actually more derived from the logistics and the ease of transportation. So what we did was...
So we started by doing one exercise of flat packing a whole unit. This led us to understand how different components of the unit should be actually considered individually, but when coming together should create a whole unit. And this was actually helping us to have an easiest way to transport those units.
So after looking at this, we actually tested for topology optimization. At first, we were looking at the whole unit, but then we realized these phases are identical and can be manufactured easily multiple times. So we went on to actually only topology to optimize the surface of the capsule. So this is actually mirrored and rotated everywhere. So we only this is the exercise we performed for only gravity. The next one, in this one, we applied the gravity and the shear force. So this is the bracing system that we got for the capsule itself. So once we had the capsule, we also extracted the lines that would be flat packed, since we were looking for ease of transportation. So this is the stress lines that we had that could be easily flat packed.
So here is the simulation of the flat packing for any quick response and the formation of the capsule itself. And here are the core and the 3 different capsules forming one whole unit.
And this is the materiality and the composition of the whole unit, the exoskeleton. For the exoskeleton, we are using the aluminum structural frame. We have walkable solar panels on the top. We have white fiberglass as the roof, and polycarbonate panels that will be becoming the skin on the aluminum surface.
The idea here was actually to use lightweight materials to have, to potentially have a good strength on all the units coming together and supporting each other.
This is one of our simulations to construct the whole aggregation on site. Okay. So coming to the interior design of the unit.
So we're having the 3 different cores. We actually designed the 3 different cores because the first one is actually dividing the whole core, where if 3 capsules are coming together, it would create one whole unit, but by 3 different usage that are not actually interacting, while the core 2 and the core 3 are a core where they are connecting the 3 arms, the 3 capsules, where we're designed to have some living space capsule, separate bed capsule, where we would have for 2 people, and we are going to have the shared bed plus a living space in one capsule itself. So this is the catalog of the different capsules and core that we designed, where we're having those composition, which can be actually interchangeable according to the need of the user.
This is another catalog showing different iterations of all the capsules. And this is basically the 3 different types of units that we could, main units that we could have. One that is where a family could live together, where there is a living unit, there is 2 people sharing a bed, and one that 2 people can live together. And the second one would be...
Sorry. Anyway.
Yeah,
So this is one of the triple studio unit that we just mentioned, with the 3 capsules divided with the core itself.
here are the floor plans of the living unit and the secondary unit. We were also able to design the secondary unit as previously stated. The first floor of the secondary unit is mostly for circulation, and since this is a common area, we also have a bathroom, a utility room, and a storage area, while the second floor always serves as a different purpose. For example, this one would be a co-working space or education or healthcare, a multifunctional space. The second one could be used as a vertical farming unit, since they would be need to self-sufficient. And the third one would be for communal kitchens. And these are the three different types. And that is...
We don't have the sound. It's okay.
I don't have the sound. Okay. That's it, actually. Thank you. Explain the models.
Oh, okay. Can you hear me? Yes. Okay. So here are the first forms that we actually wanted to study, and where we are creating those first flat packing and how these units are actually interdependent after changing and nesting the unit itself, with the pneumatic exercises with the earthquake shaking table that we created to actually find the different potential of the unit itself. Coming here is actually our last iteration, and how those units are coming together to form a community. And here we're going to find the section where we're going to have the circulation that we were talking about by using the circulation units, the secondary units, but those can be those can be used to connect different units together. And then here are the cores and the capsules where we actually designed for different users. And here is the catalog of the different units that we were talking about previously, with the base unit, which will have the base isolation, the top unit, which will have the solar panels, the secondary unit, which we call the multifunctional unit with different functions, and the circulation units. This is one of the first iteration that we have done by placing and playing like a game to find potentials between those units and how we can solve the circulation in between. This is the quasi-hedral exercise that we have done to find the solution of having that three-dimensional circulation instead of the 2.5D circulations. And those are the other exercises that we have done at the beginning of our thesis. Thank you.
Thank you, guys. So maybe I can start this time? Yes, of course. All right, so my voice is not loud enough already? Okay, so thank you very much for your presentation. As I'm getting into the mood of these year's presentations, I begin to see a lot of qualities that are being developed by through the observing the development of these very interesting briefs. And first of all, I would like to congratulate your tutors for tabling these briefs for development this year. What's interesting about earthquake resilience is the fact that you need to act quick. You need to, obviously secure human life, and you need to be able to build resilience very, very quickly. And I think, the forms that you're presenting are very interesting in many ways. First of all, I appreciate very much the simple geometries and the repetitive geometries that you're presenting, because this is exactly what's needed in these kinds of areas, to have buildings that behave better by simplicity. And I think what's interesting about it is that the stacking concepts are actually giving you this sort of flexible, tremoring sort of behavior in case of post-earthquake sort of scenarios that are typically the case. A question, and I want to engage you in a kind of a conversation with us rather than having this, positioning only, is when you're designing buildings like this, there is obviously different levels to which you can break down structure in order to be able to make it more
flexible, or adaptable.
Yes, flexible, agile, to be able to respond to these conditions. And my question to you is, for the sake of enriching our conversation, is why did you decide to stop at the level of a single unit? What I mean by this is that these sort of elements here, all of these positions, all of these nodal points inside the structure, the mesh of these individual units, could have also been designed to be a little bit more flexible. So my question is, why stop there? And have you looked at ways how to design structure that allows you to have this sort of more flexible mesh connection conditions?
I would answer that in the way that one of our brief points is that they need to be industrially manufactured and they will need to be repetitive. So breaking this down to this level was one of the easiest ways we could get to, and we could flat pack this to fit them inside containers so that can be easily transported. But you are correct in saying that this could be broken down into more at this level. You're correct about that. But I think at this stage, our thesis, we had to finish the unit itself. So this was our last point, our latest point of formation, let's say, and this could be further developed for sure.
The last breath.
Yes.
Okay.
Thank you. I think I agree with Christos. I think technically it seems, you put a lot of heart in technical solution of the units, the flat packing, the mobility, lightweight, and so on. But I have the feeling that you made your life a little bit complicated by deciding to consider earthquakes, and in particular consider earthquake-stricken communities, so traumatized communities and communities of homeless people that are in a way forced to live in the long term, like you said rightly at the beginning, not temporarily, but potentially in the long term in a completely different setting, completely different adjacency, different neighbors, and so on. And at that point, I think, I don't want to sound harsh, but the risk is you're designing a glorified container city, you know what I mean? I think you need to start from the community standpoint and create public spaces, create places where communities can reform themselves, because ultimately what you're doing is, there's a randomness of putting people together on a standpoint of just urgency of accommodation. I would think that, if I were to take this project forward, I think this should be the next consideration for you, because ultimately the risk is that you're creating, you seem to be a little bit enamored with pattern making, no? And I mean, we all are as architects, and it's a real risk, because sometimes you start looking at, you have this eye of God, you look at your urban planning from point of view, which is like, you would probably tell me, yeah, it's technical and it's regarding the kind of flexibility of nodes and so on, fine. But you are ultimately creating stable communities, so communities should be stable for a longish period of time. So I think if I were to take this forward, I would just mount the whole set and recombine it like Lego-like around considerations that are more related to how these people are going to live together.
Hi. Thanks for the presentation. I was wondering whether you have reflected on the community aspect beyond the architectural morphology, and what else can a geological force do for you, or how can we relate to it? I have few thoughts and a little bit confused, so hold on with me. But I was thinking about the fact that, in a way, a geological force is a form of energy. And can your unit becomes a shelter, but also a form of knowledge? Often the trauma that comes from environmental condition doesn't come only from the fact that we are displaced, but also from the fact that we are surprised. We don't know, we don't understand, we can't establish a relationship. And in pre-industrial society, community would define volcano and earthquake and would give them names. They would relate to it through magic and religious procedure. But what can substitute that in the current society? Could maybe data flow, pattern of data related to your unit, create a different pattern awareness of the geological languages? Can people start to understand when a tremor is a danger, or when a tremor can become energy that they could harvest? Because there is a huge amount of energy that unfolds during earthquake, right? So I was wondering whether you can go a step forward, not only in the design of the unit, but also now in I don't know, the fourth industrial revolution, as somebody call it. We can go one step beyond what the first industrial revolution has done, which is segregating ourselves from the meta-understanding of the planet, and bring vibration in number data pattern that can effectively develop awareness and some more resilient community, because the single individual doesn't need to rely simply on your unit, but can rely on its own know-how, or how we can change it, or how we can relate to it.
It's really, I mean, it's a super interesting and very complicated topic. If you go back to the beginning of your research, when you look at current solutions, the logic is that these current temporary solutions are designed and delivered as temporary solutions, even though, as you said, they often become permanent, right? But if you talk to the UN, for example, they will tell you that they don't want it to be too nice. They don't want it to be, they don't want public squares. They don't want people to feel, good to a degree, right? In those, because they're temporary. Same with refugee camps. It's the same kind of logic, right? But the reality shows that 2 years later they're still there. So I think there's an interesting problem, right? That this this whole nature of temporality is kind of, I think one can then go further and say, if you think about Istanbul, I think something insane like 70% of the housing is informally generated. Which is the similar story, right? Which starts temporarily and then it becomes permanent. And so I think there is in the future explorations, to go a step further and think about, could this translate somewhere? Could this be an experiment where we test different layouts and then, some become more permanent over time? Could be interesting to explore. The other thing that I was thinking about is the trauma. I think is a really super important point, because this is a traumatized community, and so we cannot design it in a way like we would design a happy village of non-traumatized people. And so, if you look at the interventions that are happening after earthquakes, often it's about providing much more privacy. And you said when you went to visit the current settlement in Istanbul or in Turkey. People were very separated, and but to a degree that has to do with the fact that they are traumatized, and there is maybe a need for more separation and less a happy village kind of feel. So anyway, I feel like these two things could be explored further in kind of future explorations.
Yeah, I kind of align with what's been said. I'm going to make the boring observation and the more traditional observation. I was looking, and within that do some some critique. I was looking at your circulation diagrams, because the aggregation logic, of course, comes from the geometry and the studies of the geometry that you did, which is quite interesting. And as I was looking at your circulation diagrams, obviously your circulation is way too big for the area you're disposing, right? So I was just wondering, that led to whether this is the wrong scale. Just kept me thinking. I kept thinking whether this is the wrong scale, and within could the unit have been much larger or larger, right? And could it be within that host a whole range of community needs and be more heterogeneous? I mean, in the lines of what's been said, I think. But I sense that there's a scale issue here. And with that, a little bit of an anecdote. One of my traumas was when I was in Montreal looking at the Habitat building, right? One of the biggest architectural traumas is realizing that the back has a massive circulation axis, right, with two cores, right, not facing the water, but on the back, right? That was one of the kind of architectural disappointments. I was looking into, you know, the purity of the unit kind of solving all the issues, which is the path you went through. But it seems to me that there's a lack of awareness of the different aspects that are going to happen within this place, but also, yeah, I'm just repeating myself, sorry, but just think about probably for the viability, it looks like you went into the container size and that kind of drove everything else, but I think the unit could be much larger, and within that kind of, have even a different way of thinking about structure and a much larger frame potentially that will host the units and articulate the units, and maybe units could be from one scale and maybe this larger scale units that can combine with the smaller scale units. I think the practicality of it could lead to a much richer kind of heterogeneous situation.
Well, I think it would be good to consider what would you like this development to be? You know, what do you want it to do? Because if we consider that as temporary, I don't quite agree with my colleagues that it should be a bit, it should have this feel of temporarity. It actually shouldn't. I mean, ask yourself what temporary means. I mean, how can we use the fact that this is temporary to make things quicker, easier, better, and not oppressive? So I think there is another aspect of temporarity, like, I don't know, something being cheaper, easier to build, you know, but still nice to live at. So I think the next step for that would be for you to prove that the public realm, the spaces between places are actually nice and habitable, which you might do. I mean, you are just lacking this level of detail about the gardens, the pavements, you know, how the spaces look. But then another issue I would like to highlight is the practicality, because if we are saying it's temporary and people move in without any, any stuff, they lost everything probably. They will have to buy quickly new furniture. They probably don't have extensive amounts of money to do that. And having that in mind, would you really create this kind of complicated geometry for them to inhabit? Also, you know, spaces inside, the amount of windows. I was watching all the renders. I would question that, you know. That's it for me.
I quite enjoyed your presentation. I think it's just great experiment about what's going to happen, how we're going to live after earthquake. When I recalled all the scene after earthquake, scenery is quite similar to the refugee camp. You know, the white tent is spreading by grid all the way. I think you achieved a certain aspect, especially technical experiment is quite sort of challenging. Still, I mean, it's a student level. Still, there are a couple of aspects, we need to sort of consider more. But somehow, I think you reached a certain level. But I think if you have similar level of experiment on the aggregation, I think then it become much sort of more, I don't want to say better, but somehow it become more complex. I think that aggregation may be based on the human factor. If you just probably research on the recovery process after the earthquake, well, how they gonna decide on the size of a tent and the arrangement, it's all based on the people there. They ask themselves how many families are there, how they gonna live there, and how they gonna maintain hygienes and things like that. And once that sort of time, if you probably consider from the beginning, from recovery process, from the time of earthquake to the completion, and make intervention on each point, then I think that it become more diverse, I guess. I think that might be the next step probably you maybe may consider, I guess. Yeah, that's it.
Thank you.
Just a few comments I want to pick up on what Manelo was talking about in terms of the community and shared spaces, additional facilities, and so on, which would probably lead to bring you away from that pattern knitting of a kind of 3D pattern. I mean, what I like about it is the 3D element of it. So you get a lot of interesting undercrofts and 3D porosity through all the bridging. And that's where I see potential. But they remain a kind of unfurnished outdoor spaces. So there's one point I wanted to make. The other point I want to make is, once you bring in more facilities or you respect the more variety in the, which you have a little bit here because you can combining through an empty core or filled core, but you're hiding basically these differences. And I would say that makes it more isotropic and the same. So I would introduce it. The variety you have, I accept that this is a population which there's a certain equality of distributed, but there will still be family size differences, couples, individuals, and also different type of social. So it would lead to a more differentiated field, and that's where I think the monotony and isotropicness of the singular unit, even with a singular unit, I think there could be combinatoric surprises when they're plugged to each other without the core and tilt upwards into oblique. And I think there's also some things which I feel you could have, let's say the site isn't really intervening properly. There's something in the background. So how could that, if there were obstacles, how would that weave around existing context? Would bring it all, I mean, it remains quite abstract. So in this sense, it's incomplete for me. Things like the faceting of the facades, which I don't know where it comes from. Fair enough, you didn't want to go overly simple, for instance. But I see immediate opportunity. For instance, you have these tilted surfaces and you over in void space, you have a window looking down and then somebody looking up, or you're looking up this way, maybe there's something above. So to exploit a bit more, because when you furnish these, you need to opportunize on the particular conditions and you find a mezzanine here. And there's a little bit of that going on, but I think there should be more of that. So that's the feeling. A feeling that it's not fully complete because it's still too abstract. I like the translucency. There's some things about it, but it's not yet contextualized, not yet filled with content and articulated fully. So it remains on the, let's say, system stage too much for me.
Thank you, guys. I think, yeah, all the comments were actually quite spot on in pointing out some level of weakness on the project. But I would like to, let's say, focus on what I think was quite commendable. I think the research you made on the use of pneumatics, the use of soft joints, the use of also this challenge that you take, and I feel, of course, responsible for it, because we actually say to ourselves, like, how we can go beyond the 2.5D kind of settlement, typical settlement for refugees, which is either containers or tents. No, how can we challenge that? And of course, the challenge is a complex one. But the idea was actually to respond to what Patrick and also previous comments were mentioning, which is the idea of creating potentially a ground condition that can enable more programmatic articulation and enable also like functions that you felt really important, like creating retail function, creating more social interaction, which I think in a way it's one of the successes of the projects, in my opinion. The other success is to look at the idea of a structure that is not made of individual elements, but is actually looking at the collective as a sort of potential to develop more structural resilience, work with tolerances, and try to be inventive about it. I think that's the important aspect and something we can take home from this project. And the other issue I want to say, I mean, it's important, the issue of trauma and the issue of how people respond to it and how we deal with it as architects. I think in the past, I had a few experiences of different earthquakes in Italy, but recently, like a week ago, I was in Mexico, and I encountered like this huge earthquake of 6.5 magnitude. And I have to say it was quite interesting as an experience, and of course, scary. You know, I was feeding my child, and it was 8 in the morning, luckily, which is another problem. Like if it happens during the night, you don't have really many options. I mean, it's really critical. But at that time, like what my friends came to tell me, like, we need to go out, we need to go to the road. And what happened is that they actually knew more or less how many minutes we had before the earthquake could come, because normally the source of the earthquake was like 2 minutes away from the city. That's what they knew from previous experience. So there is a way to predict, not everywhere, but sometimes you can predict, but the prediction sometimes doesn't happen with the right time frame to really get out or, you know, kind of essentially respond to it in an efficient and safe way. So the thing is, like, how can we make architecture to be more resilient in relation to these problems? And we know that you know, it's a critical and complex issue to deal with, but I think it's worth to explore, you know, new ways. I think pneumatics, I think it's actually could be quite cheap and could be quite an interesting way to respond to it. And the problem is temporary, you know, the kind of friction between permanent and temporary. I think that is another important thing. Nowadays, nothing is permanent. No? Like everything is semi-permanent or semi-temporary. So in a way, I think it's important to evaluate this issue of, as you did in some respect, of before, during, after kind of conditions. And I think it's, you know, there are issues with the project, but I think, you know, you try to address many of these aspects in a kind of holistic way, and that is something I really commend you for.
Thank you.
Thank you. All right, thanks, everybody.
Thank you. Thank you so much.
Okay, everybody, we're going to slowly get the second team up and running. If everybody would like to find their seats, there are some really good seats going on here in the second and third row. Please don't be shy. Thank you very much. Okay, guys, it's all yours.
Hello?
Hello?
Okay.
Good afternoon, everyone. I hope you all enjoy the fall presentation today. We are Team Robotic from Sparopoulos Studio. My name is Min.
My name is Sixiong Wang.
My name is Xin Ne. My name is Zhi Li.
And as the first team from Sparopoulos Studio, we want to present our thesis this year with the theme of planetary intelligence, with the shift away from the human-centered discourse about the intelligence, and how intelligence emerged and how human as a species trying to recreate it with artificial intelligence. And as previous year's project Explore Intelligence in Natural System, this year is more focused on the idea of intelligence itself. We consider the intelligence is not a given trait, but it is the interaction in between, regardless of the participator, either living or non-living form. And through participation, new ideas can emerge. And specifically for our team, we look at how architecture itself can form this participative intelligence environment. Looking back at the long history of AI, we look at the field of cybernetic, with the key figure being the teaching machine by Gordon Pask. In this case, human learned from how to type, and machine again learned how to adjust with the human, and creating a learning conversation between the two. This is not an adaptive system, but rather a conversational model where intelligence can be seen. The same idea of conversational intelligence can be found in recent AI development, with the program called AlphaGo, by using reinforcement learning, has beaten the world best Go player at that year. We found that even in this confrontation situation, both parties are learning from each other's pattern, creating unpredictable moves. So in summary, the whole idea of intelligence has always been the participating in a conversation, whether in the past or in recent breakthroughs of AI. We begin the architectural study to find that conversational model in the past projects, this being the Center Pompidou and the Fun Palace by Cedric Price. Both projects has the same logic of using adaptive architectural elements to provide a participatory system for the audience to experience and modify through the time. We could see that even though the conversation model was there, the architecture wasn't considered as a speaker, but rather the end result of that conversation between the audience. And this resulted in architectures that are fixed, act passively, and reacting to audience intention rather than actively remodel and curate the audience. We take this challenge as the starting point of our project. We argue that architecture itself should have its own agency and communicate within the built environment among the audience, creating a learning environment that architecture and audience continuously learn from each other. We consider that whole system to be architectural intelligence. In order to shape that kind of environment that we mentioned above, we took the idea of adaptivity, modularity from the two previous projects, while looking into to add the agency capacity to each of the components in that architecture. In this way, architecture is a decentralized system of self-aware agents that can learn from the surrounding and decide on their own how to self-organize into meaningful structure. We tap into the field of self-awareness, seeing how individuals are aware of its own existence, self-assembly, how their physical shape influence the architectural form, and self-organization is how large population of agents interact.
Such as environment for information exchange and knowledge creation, in its conversation to be as the fundamental infrastructure. So using agentic system as the infrastructure. We first inspired by the project Generative Agent from Stanford. Events are emergent from this easy daily dialogue. By communicating, we're involving others into our system. So we created our own biting machine. By chatting, dialoguing with each other more frequently, we use QR code as the language with between machines. What we learned from this is the machine's point of view sometimes actually, most of the time, different from humans' perspective.
This stage demonstrates the robot's basic visual perception capabilities, showing how visual input supports its initial judgment of human presence. YOLO is used in the early stage to explore how the robot perceives human posture. The system can temporarily remember individuals appearing in the sign and identify basic pedestrian states, such as moving or standing still, as well as their spatial relations to the environment. The robot infers spatial depths from 2D version, constructing a perceptual 3D environment rather than a measured one. The environment is no longer a natural geometry but structured field of agents, objects, and relations. This is the way the robot analyzes the principal components.
Once our agents are able to infer a high-dimensional spatial reconstruction for low-dimensional vision information, multiply agents can share their data with each other. Eventually, it will form its own data set to the spatial itself, which is our definition of spatial learning. The spatial data sets, the latent space, work as the form of spatial memory, providing a special implementation characteristic for our spatial system, eventually forms its self-decision for our own space. Later, we also create our own spatial data set, implement embedding our space, a capability of self-reasoning. The reflection of artificial self-reasoning will always be human are forcing agents to reinforcement learning. Since reinforcement learning still need human pre-audit to set the goal position, or somehow we cannot avoid a human setting the reward and punishment regulation, which means those regulation setting with human biases needed to be replaced by machine's own reasoning. That's why we introduced the VLA structure into the decision-making part. Vision language model providing a new perspective that is seen and analyzed from the scene. It creates its own thoughts and its own text. So we set a robot that has 6 cameras and simulation pipeline ensure our robot can read from the environment, self-analyze, and send signal to the mechanical actuator. And to distract from human order as much as we can, we set up a second-order VLA framework. Since vision language model need both median and texture as input, the first texture where human embedding is only telling the robot that our role definition, its own role definition. As the figure of vision language model, you will generate a machine texture by using machine vision plus machine's texture. The result of the second order VLM, which is the action, will guide by the machine's own mind. Those machine-made self-decision can be later translated to the JSON control file to realistic execute the action sequences, guiding it to reach its own goal. Those kind of second-order structure can also transfer for our physical fabrication robots. We also recorded the moment that our robot recognized the blue wall as actually a mirror, and later recognized the cube with the total send behavior, and the position is actually itself. By looping the see thing, do, then see again sequence several times, it eventually understands what kind of elements can be involved as the judgment condition. Those kind of intelligence showcase the most important element that can emerge higher dimensional intelligence, the capability of learning. As we study agent behavior individually. It's also necessary to study behavior of large population. This requires having underlying framework acting as a global rule, a set of regulation that these agents can reference from to self-organize behavior between agents is crucial, as many of them, when combined, can form intelligence interaction.
We've done multiple rule set and examined what physical configuration can possibly emerge from them. The key idea is that we set up a local rule between the local agents and scale it up gradually, ensuring that the architecture forming is decentralized, bottom-up rather than a top-down design can be seen in conventional architecture design. One of our first study demonstrated a particle system where each particle having their own characteristic and rule set. Together they interact as a whole, forming a pattern that changes over time. We put this experiment further to a spatial level and see how the particle groups interact. We found that with specific parameters, these particles tend to cluster and recluster, potentially creating meaningful configuration. And the voxelized model of this system was our first attempt to convert a decentralized system into an adaptive and self-organizing structure. The color codifications shown in the shape help us to better understand the behavior between agents. We move on to reaction diffusion as a more stable participatory system. The core idea of reaction diffusion is how neighboring pixels influence and being influenced by each other, creating an emerged pattern from local interaction. We conducted 25 runs and see the 2D patterns emerge from different parameters. Each reaction diffusion is a parameters, and we think that later on the visual recognition model can help us to test and to categorize different configurations. Resolution of the system also reflect how patterns are formed, with higher resolution creating higher level of interaction between pixels. So we continue to map this system into a 3D space, seeing how parameters and resolution affect the spatial form, while higher resolution generate well-defined shape. The total population of the agent usually exceeds hundreds of thousands, which could lead to a longer self-organizing sequence, but lower resolution could provide us a much faster sequence. This prompted us to have a dual resolution as our system of behavior, where the low resolution of large agents will self-organize first, and higher, smaller agents as subdivision will self-organize after inside the bounding box. The idea of dual resolution can also be seen in architecture view as big and small, exterior and interior, inside and outside, buildings and interiors, smaller agents being the subdivision of the larger one. This provides us the clue in the next part of how we construct our agents prototype.
For our mechanism intelligence, we do a lot of experiment. We tried the pneumatic mechanism and the form deformation and also the caterpillar track moving. At first, we were working on the caterpillar track moving, which is the free locomotion, and we needed vertical ascent. As we see it can rotation and climbing by using the magnet. So we add the electromagnet to make it more easy to control. We add the magnet on the caterpillar track so it even can climbing on the metal wall. So our first prototype came out. It had orthogonal movement with the grid-based climbing, but we moved forward from this prototype reason is if the same weight prototype combined together, they will fall down because the gravity center is changed. From the first prototype, we learned the moving method, so we applied at the big frame prototype, which can sliding and lifting. So this robot can free walking and also following the human. We solved the gravity center change problem by using another mechanism, which is using the gear to lift the leg, so that make the whole robot higher than another one.
The animation showed how two robot climbing behaviors by using two mechanisms, because as the big frame will be the room size and also have the moving floor, so that is the effective and stable way. After the frame prototype, we have the further understanding is the deformation as movement. We tried the frame deformation and find the pneumatic deformation as the model of the movement for the whole body. We used the air pump to make the airbag deforming as the expect order, so that the model can move following. We add the magnet on the surface of the airbag to make it climbing. After the 4-phase pneumatic model, we changed to the 6-phase, resulting the nominal directional local motion. As this small size prototype, it will moving inside the big size prototype, so the rotation moving is more fast and free. We translate the principle of the pneumatic model, make the mechanism inside use the linear actuator to deform the face. Deform the face can also achieve the same movement, even more stable and controllable. This is how two robots can climbing up through the linear actuator. We keeping update to get our final prototype, which is the integration of the behavioral models while providing the skin-friendly tactility. We improve our surface from the solid to inflatable by adding the airbag structure, and meanwhile we hollowed out the surface to reduce the weight of the robot. The whole robot structure is completely finished, which is have the changeable frame surface. We can attach the camera. We can attach the. We can attach the camera and the magnet and the stable sporting. Sorry, and stable sporting edge and the track locker to make sure the surface can achieve the certain degree. For one robot, it can self-move around, but for the local group behavior, like the climbing, it needs help that make them own behavior. As we can see from the video, when the center one wants to climbing up, the left one will move away to make sure that the center one can climbing up.
After our robot has self-awareness, it's time to bring it the ability to remember the other members in the same shape. We first train our own model using official tool for labeling these classes. Those data on the right side are actually the abstract memory for a robot to remember the past. We define behavior as the robot responding differently to inputs from the external environment, starting with tracking a moving agent within its camera view. Then we also bring the light color signal as a way of communication. This kind of interacting behavior we want to introduce is not just between machine and machine, but also machine and human. Each robot is equipped with micro cameras on all 6 faces, allowing it to perceive its spatial condition and communicate this state to other robots for assistance. Within inter-robot communication, even low-resolution micro cameras can instantly recognize similar units, triggering motor actuation. Next, we introduce a membrane structure into our model through the intelligence control of air pumps, allowing the system to freely switch between soft and rigid states and adapt to different environmental conditions. And also the robot can use a camera to recognize something to make a decision. Like the video shows the cube wants to go down, but When the hand is close to the cube, the robot stops to stop the movement and goes back because it uses its camera to recognize a hand, so it stops the movement to avoid contact. Light also functions as a mode of communication, guiding interaction between humans and robots.
After studying local behavior of 1 and 2 agents together, both communication and locomotion, we increase the number of population and see how it would work with its own agency. Our first test is using reinforcement learning, with the agent actuate simultaneously rather than coordinated movement. This prompts us to design our own reinforcement learning model, assuming the coordinated movement. This way we can start to see how agents self-organize together. With local, small populations agent study in the last stage, our next step is to provide them with a local rule set as a guidance on how they can self-assembly in large scale. We look back to our study of reaction diffusion and look at it as a spatial value. As the patterns continue to grow and fill up the total building space, we can filter out the spatial position with the highest value. In the actual sequence, after the reaction diffusion sequence creating the spatial value, the agents, either the large agent sliding or the small agents rolling toward these value, and cooperate in self-organizing. As we move to the last step of realizing this architecture prototype, we choose the site of Centre Pompidou as our experimental ground and see how this model of active architecture participation can help improve the idea of what's already being there. We treat outside and architecture as a learning environment where both audience and architecture inform each other of how they behave and forming spatial configuration. This interplay of multiple participators is what we call architectural intelligence. In our agent model working in different time phase in this scenario, large room size agents forming the large space, working in a much slower time frame. Reconfiguration happens daily, carrying maximum of 1,000 small agents. The floor agents, part of the large agents, help forming different function space inside the building, reconfig hourly, and the small agents being carried around in a large agent will actively self-organize as the furniture and interior of the building with much higher frequency. We also study how to integrate intelligence study into the architecture implementation. For this, we use LLM model and prompt engineering framework. One prompt consists of data collected from the current configuration. And as LLM is a prediction model and work using prompting logic, we think of our individual agents as observer of the larger system, observing the activities inside the space and giving its own opinions. In this way, the final decision to change the parameter of reaction diffusion will be formed as an informed decision of all the agent population. With this method, we don't optimize the architectural agent to adapt with the audience. We let them self-organize as the way to communicate and learn from the audience, even trying new configuration without critical stress on the optimization. Take example 2 observation of this section of the building. 2 agents observe how the audience interact with that space, write their own observations, and then this function area can be reconfigured based on these observations. To further improve the quality of the total LLM decision, we also record the analysis of each building configuration and map it into a patterns that can then be translated into the machine learning. With a sample of 150 configuration, we begin the machine learning progress. This will give us the idea of how parameters of reaction diffusions affect the shape outcome. The final result is a latent space where data of similar features are clustered together, including explored and unexplored data, giving the LLM system information to further do the parameter tuning. We can also see the different clustering of architecture configuration based on the specific features. Going to the self-organizing sequence. Firstly, the reaction diffusion provides a signal in low resolution, creating the spatial value for the larger agent to self-organize. The large agents will firstly construct the support structure to help others reaching the higher value with higher spatial points. With different parameters, different spatial values are generated, and so are the architecture configurations. The second phase involves platforms to create different function space, learning from human inputs and change actively throughout the day. Lastly, high-resolution reaction diffusion signals are created in each single function zone, with the small voxel self-organized into the interior of that space. And this is the full sequence of how the architecture can operate in a day. First, we can see the sequence of large agent communicating with light communication and reaction diffusion signal to self-organize into the exterior structure. Next, then the process of function clustering happens with the floors moving through the grid of constructed space. And after that, each function space generates a different reaction diffusion patterns, guiding the smaller agents to later on aggregate. And in the final phase, after getting the reaction diffusion patterns from the floor, the smaller agents will start to aggregate based on that pattern and the spatial values. And that will be the end of our presentation on architectural intelligence. We thank you all for listening. And here we would like to present our studies on the model agents. First, we experiment with the smaller voxels, the smaller agents. First, we study with a manual kind of actuation robots. And when we have the intuition on how these robots can roll and can climb and self-organize together, we start to move on the physical mechanical models that have more precision in the movement. And the next one is the larger frame agent. Firstly, we try with a two-directional train tracks, so it can move in a grid kind of movement. Sorry. And after we get the first test on the two-directional moving robots, we find that these robots cannot take any of the smaller agents inside, so we need to figure out a way to put more of the smaller agents into the shape. And then we come to this model right here that we built. This one will have a larger capacity in size, and also all of the movement will be moved to the four corners, so the space in between will have much larger room for the smaller voxels. And in terms of the self-organizing rule set, we first try with this kind of particle-based simulation, and this is a one-size voxel system. And then we move on to our reaction diffusion model with dual resolution. And in this final model, you can see here, we have the large voxel size, the agent, and then we have the small agent size. Thank you.
Thank you very much. I didn't get this when we started today with the first presentation, but I really appreciate that you start to investigate this new technology really from the ground up, and you start engaging with, in a way, the smallest understandable units by doing it yourself. I hope you're doing it yourself. You're not getting AI to do it for you. But I think that's a really important moment in time that we are right now, where I think it's the right approach. I think it's what we all have to do in a way is we have to not just learn a language, but experience the process, right? And I think that's, it's great that you're doing that. I'm really happy about that. I also think it's great that you then translate this into the physical and this kind of back and forth between the two. This is really day one of a very new technology that it feels like as if we already have arrived somewhere, but the reality is that people just committed a lot of capital to the first idea, and this is why it feels like we are already somewhere. In reality, this is really the moment now is where we have to define the vocabulary of how we describe things. We have to think about the ontologies. We have to think about the semantics that define architectural space. I think it's actually a really interesting moment where the whole profession and all of the people who are working in the built environment actually have to come together for the first time and agree on things. What I mean is that humans are very good at lying to each other, and we can still get stuff done. If you're on a project, everybody has their own perspective, everybody has their own view, everybody has their own incentives, everybody has their own, and we kind of wiggle our way through, and in the end, there's a building or a master plan or something, right? If we want this technology to support us, and I think that's, you are learning that through, in the way that you're engaging with it on this kind of ground level, this technology, when there was big data, people were talking about rubbish in, rubbish out. With AI, it's a little bit of rubbish in, a lot of rubbish out, because of the reinforcement logic of the system. And so I'm really convinced that it was never more important than now for us to come together and not only clarify what we mean and how we define things. We all define things differently. But secondly, I think it's also the most important time for us to define what it is we're trying to achieve. So the underlying values that we want to see emerge out of this dialogue between us and the technology. And so I think even though people talk a lot about technology, I think it's actually a deeply human moment where we have to come together and be honest with each other, because if we lie to the machine, it's just going to propagate those lies, right, and reinforce them. And so I'm really curious to see where this is all going, but I'm happy, just to end on that, to see that you are starting where I think one should start, which is a hands-on engaging with the actual logic and the actual code, and learning it by doing it is really great. I think it's a great studio.
Yeah, I love it as well. Is that working? I just have a number of questions. So first of all, I mean, it's interesting that in the model you haven't completed the larger grid, and I like the two kind of scales. I guess it's 4 meter and 50 or 4 meter and 40. And here you seem to be kind of insisting on a kind of completed griddedness. Although there will be potential for removing also some of these larger modules if they're tied together with, of course, there will be structural constraints. So it would be kind of tension or pressure, force censoring, or some inbuilt rules which allows you to bridge and scoop. But I like really a lot is these kind of concave scooping spaces which emerge. Now my question is, which wasn't clear to me, the way you are steering or guiding, if at all, the diffusion algorithms, kind of, in terms of setting up on both scales, because you're coming in with the, which I love a lot, the kind of the audience, inverted commas, or the human populations being attracted. So what's the interplay? That wasn't clear to me. You're talking about you know, I wasn't sure. The system observing, people moving. Have you worked on any of that yet? Or because all these sort of generic patterns, which have an intuitive spatiality, which understand these concentric arrays and concaves, and what would be your thinking of, you know, is it an initial offering and then the human reaction leading to secondary transformations? So that remains a bit unclear. I mean, I love the architecture and the translucency, but the dynamics of interaction with programming or those abstract programming schedules, what determines that? It's unclear. For me at the moment, it's just the diffusion patterning, which seems to be as an interesting abstract mechanism, but how is that steered, how is that set up, how is that interacting?
Thank you, Patrick, for your question. I do agree that with your comments on the previous discussion, is that the reaction diffusion in some way is sort of a undiscovered, a uncontrollable kind of patterns. So that's why we listed in our presentation that there should be some sort of method to find out and categorizing all of that reaction diffusion parameters. And also, what is the kind of effect on the human while experimenting in the space of that reaction diffusion? And that's why we creating the observation of the camera and the depth map, and also of the human labeling, to see how the people actually enjoy the space of the reaction diffusion. And after a while, like 20 or 25 or 100 of iteration, the machine, the LLM, start to understand what kind of parameters of the reaction diffusion would create the kind of space that the people want to enjoy in that. Yeah.
Hi. Thanks for the presentation. I also enjoyed the project. I really appreciate the historical introduction that shift the concept of AI clearly from optimization tool to a speculative one, which I think it's an important conversation, not to end up in the gadget, but to actually use the tool that we have at our disposal and create conversation and speculative framework. I also very much appreciate the aesthetic of the model. I think it's really elegant. Although, okay, now I'm going to make a joke. I'm missing the pipe. I don't know if it's a joke that you understand. The Pompidou is one of my favorite buildings, and I love the fact that air pipes and M&E pipe, in a way, or elements that have to do with electricity, air, and etc., become part of the aesthetic of it, right? And so when I see the point cloud, I was starting to see this minimal path that will deconstruct all the pipe of the Pompidou in a new, but that was my morphology. That was my imagination. But in your case, I don't know what you think is the aesthetic, and the aesthetic is also a language, that emerge from this conversation. Is the one of the inflatable prototype with these clear pipes and mechanism, or is the one of the sort of point cloud abstract with different resolution? I think it's important that you reflect, because aesthetic is also part of the language, and cybernetic, it's a language of communication that also happens through material. Gregory Bateson talks a lot about the fact that cybernetic is a language that interweave logical languages with meta language. So I think it's important in a project that deals with languages to reflect on whether you want to go in this direction or that direction, or what do you think could emerge. Speculate on that, and then maybe something else. emerge from the game. But at least I think you should envision direction, simulate direction that could forecast a visionary future, because in that way the AI become a speculative tool, in my opinion. So what do you think?
Thank you for your question. I would like to answer your first opinion about the Centre Pompidou. What we think that is similar to the Centre Pompidou is the metaphorical and also the framework behind that. In terms of materiality and functionality, we want to show the function as how they work in reality, similar to the Centre Pompidou with all the exposed pipe and the steel frame. And also in terms of how it functions, saying like how the people, the audience gets inside the space and they can interact, they can communicate with the architecture to reconfigure itself. So in the case of Centre Pompidou, I would say that most of the time, like the human or the audience would be the one who reconfigure the space. But in our project, our aim is that that architecture itself should be agentic and self-decide how it wants to move, how it wants to react, or even how it wants to curate the audience. Yeah.
And because we have limited time, let's leave the microphones with our critics. So they can... Guys, we got 3 microphones.
Yeah, I'll be quick. I'll be quick. Yeah, just want to congratulate you for the big effort of making the whole, setting up obviously all the logic and making the huge effort of making, of producing these fantastic models. The work is quite impressive. Yet, much has been said, but I think it's more a suggestion what I want to give you, because I've always quite skeptical about research research projects presented as finite or complete. So in that sense, I think it'll be good in the lines of what Claudia was saying. It'll be fantastic to see what else can the system do. I know you have a time frame and you haven't slept in weeks and all that, but it's so exciting, and all the kind of how the logic became the mechanics of it, and how the logic fits into is the physicality of it and the appearance and all that's been said. That I want to see more. I want to see pipes. I want to see how. I understand. Obviously, you won't be able to finish, but I think you were too safe to present your work as a final product when it's not, and actually the huge potential that your prototyping and your models have makes your render look a little bit shy and a bit sad, I would say, compared to the models and the videos you showed. The other thing is that I just want to say that I think it's a fantastic idea, and I'm not sure who was it, but a fantastic idea to use the Pompidou and the problem of the Pompidou, the theoretical framework and all that as a platform to kind of develop your project. Congratulations, fantastic work.
Yeah, I'd like to echo quite a lot of that, but I think there's some really interesting questions that your project poses. And perhaps this question of a complete idea or a complete iteration of the project really poses a question of who it's for. And I don't think it's necessarily a system that learns what people like. You introduce the project as related to planetary intelligence and actually moving away from the human. And what I find particularly fascinating in relation to the project and with AI is that it feels like a logical stage in the move from, I suppose, architectural and structural hierarchies through to complete diversity and pluralization, through to this idea that somehow either through instinct or through the introduction of intelligence as a form of making connections between ideas and things and entities, that we're moving towards some kind of collective. So that design becomes a collective act that's initiated by a collective intelligence that is either artificial or non-artificial. I'm still living in Cambridge, so I have the privilege of taking trains with interesting people. And I was on the train with an old friend who started out working at DeepMind and now is working for a startup AI company. And he was saying, you know, from his perspective, that what AI is doing is it's breaking patterns of privilege. So before you had things like ChatGPT, you could detect someone's class or their privilege or perhaps infer their intelligence by the way in which they wrote or presented themselves verbally. And through the intervention, we've begun to eliminate, from his perspective, a series of boundaries. So again, this goes back to that question of kind of connection. So I think it was interesting from also his perspective is that the startup that he's moved to is actually involved in security. So it's all about producing new forms of barrier. So out of this incredibly democratizing system, where your system is continually learning, maybe not from humans, maybe from something else, maybe from itself, that there are infinite possibilities. And the question is whether that infinite set of possibilities is ultimately a good, is ultimately forever open, or is on the cusp of being shut down. So there's some really interesting questions here, and perhaps rather than this being a complete system, I'd love to see 100 variations, because I think there probably are some, and then certain patterns that start to reinstate themselves and form a kind of norm. But perhaps it's a question of taking a small corner of this and understanding the implications and letting your imagination run wild. Letting your imagination run wild beyond the capacity of the human, that this is not just a space for human inhabitation. It's a space for machine inhabitation. It's a space for alternative kind of planetary intelligences. So you've opened up a set of questions, which is just what a project should do. Thank you for taking it to this stage and prompting a really interesting conversation.
Yeah, I feel we are all on the same page here. I mean, you went into a very deep level of technical detail, which is stunning and impressive. But it feels like, you know, you didn't really ask yourself, where are we going, you know? Why are we doing all that for? What strikes me is that if I'm investing so much money into this system, which will not be cheap, and apologies for being commercial, but say we want this to happen. So how do you prove your investor that he should go for it? You know, what is the extra commercial value the building will generate by introducing this system? And just to echo what others were saying, I mean, a little bit of case study would be useful so we understand, you know, what is the system reacting to, what is it doing after the conclusion it makes, and, you know, how is it looking? Because I don't think this is the final product. If it's a building, you need to think about isolation, you know, materiality and other aspects like that. So a bit more study would be good.
I mean, there's an interesting comparison precedent. I'm not sure if you're aware of the new Alibaba headquarter by Foster in Shanghai. Have a look. There's an interesting synergies there.
This is a game of hot potato. Did you want to say something?
I really appreciate that you basically have taken intelligence and giving it a physical, architectural form to express its behavior. And in that way, you present a new creature, which is a reconfigurable space, which is completely automated and self-initiated and self-organized. So to me, what it means to inhabit that space, whether you're human or any other living creature, of being a passive inhabitant in a space that decides for itself, is really interesting. And even what can we accommodate in that relationship, and how do you negotiate that? In one way, the only parallel is nature. In nature, it is dynamic, and when we exist in nature, we accommodate its reconfiguration. But it's in a very different time scale. It's in a very slow time scale. So it's actually interesting now, if we have this framework, to be able to test what are the limits of what we can accommodate in terms of dynamic behavior as living creatures, as any form of inhabitant. Just a further question.
Okay. Sorry, I'm just trying to be civil.
I could add.
Christos, okay.
Oh.
Sanjay, I've heard him for a year.
No, I could add a few words actually, since you.
I was just using delaying tactics to get your confidence up. Let's go.
No, again, thank you very much for the quality of the work you just showed. I cannot help myself thinking about what could be the potential of what you are proposing. Far beyond just the spatial quality of the reconfiguration. I also really like the fact you chose Centre Pompidou, maybe because I'm French, but also because I think it does a very good link with that idea of the plan libre of possible reconfiguration, and that's an opening to what it could become. The only question I was wondering is what extra quality you could bring to these units. I think it does a link with previous work we saw is all about fluidics. I'm thinking we at Interstellar we work with plants, and that idea of modularity and reconfigurability is essential because we work with living systems that grow, change shape, and that possibility of reconfiguring based on living systems is essential. So and that question of the interface between your small units so that you could recreate continuity for all the fluidics, whether it is water, electricity, all that, could be interesting to push. But thank you.
Maybe I can ask some more questions also. Thank you, Theo and team, for this project. I must say I'm struggling here a lot, and I'm a bit embarrassed to admit that I even don't know what question to ask precisely. But I think beyond the evident, self-evident qualities of the robotic system that is being presented, also beyond the challenges and the capability of programming such systems, there are questions that a lot of people here, a lot of jurors have asked. And I think I understand them in two ways. One is, and they all revolve around this idea of what is the end game here? What does this experiment lead to? I think we all appreciate that the experiment has a lot of interesting potential or a lot of potential interest. I'm not sure which of the two. I think also it's interesting when it's being compared to the Pompidou, the Amazon factory, and so on and so forth. But I think the critical questions to answer here are the basic typological, architectural, urbanistic ones. Yeah? I think it's interesting to, if you want to reconfigure the city or the building, and Patrick, forgive me, but I think the Foster building comes a little bit short of what the ambition might be, because the minute you fix it, it's the same problem we had with conversations with Jeff Kipnis several years ago about the raison d'etre of the parametric. The minute you fix it, it loses its charm. Yeah? And therefore, to keep it in movement and in a dynamic, continuous reconfiguration, we have to rethink what architecture can be. And I'm struggling personally, I said shamefully in the beginning, because I don't know what that architecture can be. And I think it's important that in parallel to these experiments, that there is another thought process that begins to reinvent architectural typologies. And I'm thinking Cedric Price, the Pleasure Palace, and a lot of other playful, at least initially, let's say, typological experiments that can begin to give rise to a new way of utilizing space that we have not yet seen. And I'm wondering, what are your thoughts on these questions?
I can answer this for many different ways, and I think I would bore the audience completely with a lot of cybernetic discussions and probably way too many gray hairs on my beard. But I think the most important thing is to critically be aware that there are probably 3 words that were from the early days of computing that play, I think, an important role today. Is what we mean by control, how we explore learning, and I think in some ways what communication means. So most AI systems are human-centric. They're looking at human data. It's an acknowledgement that there are other forms of intelligence that are operating in the world. And the question, I think, is more not so much about some of those questions that Cedric Price and John Fraser and others were talking about, which was a kind of tangible computing or a reliance on the participants to kind of program space. I think if we're looking at AI systems is to really look at, I think the word was used, collective. What is really a kind of collective intelligence is something that is plural, is not based in the now, but has the ability to learn, is goal-oriented, and has doubt. Because I don't think that this architecture is going to be something that is not without doubt. Because the reality of the things is that the systems themselves, for them to truly be learning, have to continuously also have their form of problematizing what it is that they're seeing, what they're looking at. For me and their project, I could imagine the moments that I find interesting is when the little agent saw itself in the mirror. Because it's the one moment where there's like the diagnostics of actually just trying to describe what another agent is, at some moment falls apart. Because the difference between the image of an agent and an agent itself, and it's the same thing, which was one of those first kind of cybernetic things. What color is a chameleon in front of a mirror? That was asked to all of the cyberneticians in this kind of Macy's conference. Each of them had an answer. Every one of them was correct, but they were all in context. And I think that this is the thing, an architecture that's in time, that understands that there is uncertainty, that change is important, and then that tries to qualify what is meaningful change. So one aspect of a lot of this stuff is that it can iterate, but not every difference is a meaningful difference. So a change in form doesn't necessarily mean a change in behavior. I think a lot of the work in the parametric world, has an amazing vitality, but it also makes certain assumptions to maintain that vitality. So this one is coming much more from behavior, and it's not making the distinction between robotic agents and human agents. These are all kind of participants in much more of an ecology. So when Claudio mentions Gregory Bateson and all of these characters, I think they really problematized a lot of the things that we find ourselves in today. They didn't have access to the technologies, but they did these what-if experiments. We are living in a black box right now. Technologically, it's 100% the case. And so I think we just need to be able to problematize new ways of asking questions. The only thing I could ask about the team is, I think that you should give yourselves the capacity to present this project completely other. Like when you say learning, how do these things learn? What are they trying to find out from each other? You mentioned biases. These robots will also have their bias. They're going to evolve their own personalities. They're not always going to play nice. So I'm just thinking in terms of like, if you had a way to present this project completely from the perspective of the robot, does the robot really want us to be there? I'm not sure. The question is like, all of these scenarios are plausible. I think an architecture that can continuously reconsider itself would also have to reconsider the terms it's relating to us. But I don't think that this is human-centric. I think it's human-centric by being really clearly non-human. And that's also the fact that we look with empathy to these robots communicating with each other. There's Boston Dynamics videos of people kicking robots and everybody online going nuts about traumatizing mechanical systems. It's a very human characteristic, which I think we also have to acknowledge. What actually defines us in a much more human way, in the way that we communicate, in the way that we behave, in the way that we understand. And I think the same thing we should be asking about our environments that we're constructing. The point is, I don't think that there's a right answer, but I think the effect that there's no blueprint and there's no master plan is a good start for architects to consider that this is a kind of very plausible reality. And I'm going to leave it there, and we can have a beer or 10 afterwards and go in deeper with it. Anyway, thank you guys.
Can you move it a little bit, very little? I'll help Yash.
Yeah, I think it's okay. Is it?
Plugged in?
Yeah, I plugged in.
Is it the same computer as before? Or is it your computer?
It's my computer.
Okay, cool. Because that one was flashing a little bit, the previous one.
Oh, really?
Yeah, this one looks okay. Cool.
Okay.
Nice. You have any audio?
No, we don't.
Cool. Can I just bring this a bit closer to you? Is that
Okay, sure. Yes? Okay, I can lift you. Silvio.
Can I? Yeah, just trying some drugs.
Try some books. Keep calm, slow. 1, 2, 3. 1, 2, 3. Is it pen?
Yeah. Good evening, everyone. We are Team Verticity from Bushan Studio, and my name is Divya. My teammates Yash and Ashwit. Our studio brief is AI for new cities. Our studio treats AI and new cities not as parallel themes, but as mutually conditioning problems. Instead of designing fixed buildings, in this sense, studio design a process where urban form emerges through data and spatial logic across scales. New cities are framed as a central architectural challenge of coming decades. By 2050, an additional 2.5 billion people are expected to be added to the world's urban population. The scale of urbanization renders the construction of new urban fabric unavoidable rather than speculative. Therefore, our studio treats new cities as engines of prosperity and employment. Rising population and economic concentration intensify pressure on existing cities. Jobs, mobility, and housing demand outgrow current capacity, making the development of new cities necessary to sustain growth and opportunity. So we go through the thesis, AI for new cities, and get into the game AI research and key discoveries, transitioning through shape AI, and then that gets to procedural building system and research discoveries. Moving forward, the studio draws on a lineage of integrated architectural urbanism, spanning contemporary research from the AA Design Research Laboratory, including parametric urbanism and adaptive ecologies, which frame cities as dynamic, relational, and evolving systems. Adaptive ecologies teaches us to see cities as living systems, and parametric urbanism gives us computational processes, which led us to learn about von Neumann's payoff logic as a framework where urban form emerges from interactions between agents. Design decisions are not singular, but negotiated through variable outcomes. We use a two-player game to clearly understand interaction between competing urban forces. John von Neumann's theory helped us structure decisions using payoff logic,
showing how each player's choice affects the other, and this framework allowed us to stimulate controlled, negotiated urban outcomes. Simultaneously, Geoffrey Hinton's multi-layer perceptron introduces latent space and representation learning. This becomes a key reference to understand how spatial forms can be encoded, learned, and reconstructed through hidden representations. This is a comparison between AI of 2025 that we know of currently and the AI of 1986. On the left, prompt-based models translate inputs into images or videos, lacking in latent reasoning, objectives, and dynamics. Many current AI urban visuals lack learning logic, and they show outputs without latent space objectives or feedback loops. So hence we did an in-depth exploration of latent map, which is encoded by two types of input spatial data and decoded back in geometry. And the latent space allows smooth transitions between conditions rather than abrupt formal changes. This illustrates latent space navigation of SDF-based architectural inputs. Multiple SDF fields encode spatial constraints and geometry as continuous data, and these high-dimensional inputs are compressed using an autoencoder into a low-dimensional latent space guided by loss functions. By navigating and blending within this space, architectural form emerges. And so this is multiple latent positions generate different architectural outcomes. Each output is a learned variation rather than a manual design option, enabling controlled diversity within a single system.
And to start out is Battersea Power Station serve as an example to understand the importance of an infrastructure as an urban catalyst. During 1930s to 1980s, power station provided approximately 20% of London electricity requirements. However, in early 1980s, it became obsolete. It was then considered as a catalyst to generate employment and develop housing for its region, setting an example for regenerative urbanism. Data center is an important infrastructure to the age of AI. Conventionally, data center is not related to the urban development, having large size and compact into clusters. These days, data center become giga-sized to serve the new wave of AI technologies and fully in an isolation from urbanity. Conversation of new types of data center even pushes them beyond the use of daily life and completely cannot generate urban growth as infrastructure. Similarly to today, we consider edge AI data center as our catalyst to generate an urbanism. Edge AI data center is the data center which is used for edge computing, meaning close to users, to reduce the data latency. This type of data center, we have smaller footprint and focus on AI inference processing, not data training. With its size, edge AI data center can collocate within the urban fabric and catalyst urbanism. With technological change, it can be decommissioned and transformed for other uses and leave behind the electrical and water supplies. Here's an example of how we imagine that the data center block can be transformed into other programs, such as retail, and is done not by disturbing any existing fabric. Edge AI data center attracts a specific niche of industries, which are dependent on edge computing and needs to be closer to the data center, such as gaming, financial technologies, AR, VR, and healthcare. To start a city, we look to Swansea to serve as the site to study. As the second largest city in Wales, it has a location with potential for connection, emerging into innovation economy and population growth. This can be a starting for a prototype a new city with an economic catalyst. In this show, the site situated between the hilly terrain, sea, and valley. As it's situated in this geographical condition, the land that is more constructible is less. However, as we learn from Hong Kong, prosperity of a city, such as population and economy, can also emerge from such geographical constraints. Vertical urbanism, which emerges from land constraints in Hong Kong, results in urban growth, vibrancy, and less intervention to surroundings, as observed from built-up area percentage. Referring to the book City Without Ground by Frampton, Solomon, and Wong, three-dimensional map diagram of multi-level city of Hong Kong show how the vertical urbanism triumphs the connective growth of the city, and the city itself becomes three-dimensional. Strategy which we learn from this is integrated program and multi-level ground serve as the basis in our thesis.
To start a new city, we began the study of agent-based simulation to understand the emerging pattern as a result from demand, land value based on business center and residential. We applied the same method to create different scenarios by varying the number and spacing of the city centers, resulting in different configurations of the vector field. Here we can understand the probable orientation of the building through these three iterations. With the application on the land, we can see how the vector field performs along with the orientation of the buildings. Combining with the FAR rules, we can understand the density in terms of space.
With geographical constraint, we apply the vertical urbanism as a framework to new cities. The projection of vertical urbanism has been in conversation for the new city to solve density and constraints. In this, we see potential to create a vibrant and connective urbanism. To summarize, we adopt the AI data center as a generator of the city using vertical and mixed-use urbanism to form the city fabric and create a city with interweave connectivity.
After thesis, we move to our research part. Starting with the game AI, we cover urban economic equation and move towards reinforcement learning to develop the two-player game. To start with the game, we consider two players for our urban economic equation. Those are economic developer and city developer. Economic player is responsible for building data centers, and for that it buys land from the city developer, and a revenue generated by the city developer. Now the data center has been built, the player one plans to build office spaces over the data center. Using the revenue generated by the city player, housing development is planned and initiated. After this, both the players begin taking turns in the game, and in this way, the economy is initiated by player one using edge AI data center as a catalyst, while the city player fulfills housing and public infrastructure demands. To develop a game-based urbanism model, we began the development phase by defining two players and their respective building agents. A terrain and waterfront-based game board is considered, reflecting the constraints of Swansea. Initially, we worked with simple rules with the objective of achieving maximum revenue. In the later stage of development, we plan to incorporate a reward matrix into the training process. This matrix follows a Nash equilibrium logic. If the outcome is negative, development stops progressing, whereas if the positive development continues across the site. This logic helps deliver the best possible outcome. We then run the game, analyze the win-lose conditions, and iterate further to train and define the game model. In this development phase, we introduce more complexity into the state function, and the land value logic is implemented across the plots of the game board, requiring agents to consider changing land values while making decisions. As a result, the agents and the environment operate within a continuous feedback loop. In these three phases, we implemented the action, state, and reward functions of the game. Finally, we implement the urban economic equation in a more detailed manner, considering the construction of a 4 megawatt data center as one complete cycle. Up to this point, the game has not been explored within the specific context of our city Swansea. Therefore, we move to the next phase, where we plan to develop a site-specific game board starting with the incorporation of the existing road network. Next, we derive a logic to define the city centers. The primary scoring factors used to identify the centers are walkability and the availability of the buildable land around each center. Based on this scoring, we select 3 center options to carry forward. Then we move on to consider different types of agents for each section of the city, where at near the centers, the data centers and the office players will take place, and far from the center, the residential agents will place. And then we apply circle packing logic with different size of plots, where the big plots will be occupied by the office agents, office buildings, and some of the public buildings because they need a larger footprint area. Going forward, we apply the vector field logic, where we have added a scoring logic based on the attractors and the deviators of considering the terrain. We use the same circle packing logic to derive a shape gradation considering the scalar field and the height field. We use all this information to create a game board to run the game. In this development phase, we applied a land value logic and add more complexity to the game, added logic to the bridge construction and land value feedback loop. Then we take the center, the context, building locations, vector field and parcel generation as our recipe. And then we move forward to create an urban fabric based on vector field and parcel generation. We add a massing over the parcels we created based on the game output. So the game output can be compared with the circle packing logic, where the buildings with the larger floor area are placed near the centers, and as we go further towards the terrain and the waterfront, the floor area decreases. And here we can observe how the different multi-level works in the city with the ground level connections, podium, and the mid levels and the terrace level connections.
After we get the result from our game AI, we move to the shape AI. And so we started with exploring 2D sign distance fields using the directional primitive shape as a core spatial representation. And what was crucial for this research is that the same logic operates across scales from 2D to 3D. Once the spatial logic is established in plan as a sign distance field, the same logic is propagated vertically to construct the tower. And the spatial logic remains continuous across the entire height, allowing voids, gradients, cutouts. Once we defined the spatial conditions as SDFs in plans on the left, the network learns to reconstruct SDF values at sample points, guided by a loss function that preserves spatial distance accuracy, and the main goal of the loss function is to accurately reconstruct SDF. The autoencoder compresses spatial data into latent space and reconstructs it. Lower loss values indicate improved spatial understanding and smoother reconstruction across tower heights. And different programs, data center, office, residential, and commercial, are distributed vertically based on site conditions, such as slope, height, and proximity to sea or hill. This is the training, latent navigation, and blending from a continuous workflow. Architectural outcomes are selected by navigating latent space rather than redrawing geometry. Each iteration represents a different latent trajectory. Programmatic transitions occur gradually, producing different outcomes. For the business district of our site, we are proposing office towers with different number of cores. This one is a 3-core office tower, described simultaneously as a field system, a set of latent outcomes, and a resolved architectural plan.
The video demonstrates how a simple latent structure can generate multiple expressions without changing the input shapes. The same logic is applied in the mid-rise office tower with the 3 cores, but with segregated units as we move across height. Different program mixes are achieved by navigating latent space, allowing offices to shift into hybrid commercial or shares. This is the 1-core high-rise. A single-core configuration maximizes usable floor area and demonstrates how 1 core influences spatial density and circulation patterns. The view shows iterations demonstrate controlled exploration rather than random variation, ensuring architectural intent remains intact.
In terms of integrated architectural and urbanism, for the office building with the data center we envision to have the location at the base of the building. To minimize the construction and future adaptation difficulty and maintenance, cooling plant will be on the top of this part of the data center. Its facade can be used also as the media wall for advertisement or digital art display, which can interact with urban environment and also generate another source of revenue. The open ground lobby, the data center part will be lifted above the ground to open space for the public or other programmatic users. The tower, as locating near to the city center, we have larger floor plate to serve the demand for large firms. While going through the building will bring more natural light into office spaces and create 3-dimensional visual connection in the building and also to the surrounding. This shows how the space inside the office is envisioned with the atrium. The connection of atrium improved the connection to the upper part of the tower as well, of this high-rise building, which can potentially, that we can create a sky garden or other leisures communal space. For 2 core buildings, the space between the cores can be allocated for vertical connection also. For the connection, which is the space inside and outside, can be the place of gathering or commercial. It can create an entrance to different levels of the city. And this part, we show the space which is in between, which is potential to create a connection from the ground level, which has the podium, to the bottom part of the tower, which leads to the office part. And 1 core, the single core type of the office, it is potentially that we have the uninterrupted space surrounding around the core and have the layers intervention to the ground level, and we can have the open space and low-rise building beneath the tower. To the building system to the structural system of the building, we divide them into 2 parts, which have the mid-rise to high-rise part, and podium to or low-rise part. The mid to high-rise part, we will use the suspended structure, and the floor plate structure. The floor plate structure will not support from the ground, but from the suspended structure instead. The low-rise building can be built separately by the bottom-up construction techniques without any intervention to the high-rise structure. Here is to show how the potential of the construction phases being divided, separating between the high-rise part and the lower part. It is redefined by lifting the structure by the core, and it can have the potential to separate into different phases, also for the vertical expansion above. We studied different ways to create the suspended structure of this high-rise building for different uses, which can be observed on this pattern. Also through the model that we have done by the chain. The suspended structure will be suspended from the truss cantilever from the core by using steel section bifurcated as per different requirements, internal and external perceptions. The space between each suspended section can be opened as the open space. These are the building types that we implement the suspended structure as per uses and size. Suspended structure that we have the cantilever truss could also be used as the support between the towers as well as the bridges to create the public uses in between and create another layer of new ground where different programs can be allocated. Also, the bridge will create a network of connection from the higher elevation to the city center.
So we applied the same SDF logic to create the mid-rise residential buildings with the latent space, and residential density shifts vertically while maintaining equal GIA. Mixed-use blending occurs through latent control, allowing retail and residential to coexist smoothly. And this typology focuses on mid-rise living with balanced density and shared spaces. The view emphasizes this view emphasizes terraces and vertical continuity. We try to add the language of balconies in this type of residential with the help of SDF. This is a field of SDF outputs for the mid to high-rise residential buildings. This is the architectural application of a mid-rise residential tower with, on the hillside with connectivity. Then we move to the low-rise hillside condition. The hillside condition used stepped latent forms to adapt to slope while maintaining spatial connectivity. This is the SDF application to the architectural language of the low-rise hillside residences. And so we apply the same learning workflow applies to low-rise context, proving scale independence. And we tried to apply the same logic for the waterside low-rise residences, this time adding the language for balconies to maximize views. And all residential types belong to a single system rather than separate designs. This is a low-rise residential floor. Structural components are modular and derived from a spatial logic. Low-rise housing uses prefabricated units, and here we are user-based. This is the architectural application of all the residential mid-rise.
After this framework, moving from game AI to generate urban growth, to the shape of building expanding with the AI technology of latent space, we produced this urban proposal for the city with Edge AI data center as catalyst and integrated architectural urbanism to respond with geographical constraints. Thank you. And here is our study for the tower with different floor plates as the morphology of the tower. This one is the shape morphing that we use the SDF to generate. This one is also the shape morphing, but in having the bifurcate part and different details of the building. This one we have the data urban density study relating to the placement of the city center. This one is the concept study for the urban high line connecting from the higher elevation to the closer to the sea part. This one is the urban height field that we use that we generate to see the gradation of the size and the height. This one is the urban vision that we envision how multi-level public space can be connected and relating to each other. This one is the iteration of the urban, which is the result of the game. Also this one. And this one is the study of the structure connecting between the tower and the cluster. This one is the suspended structure model that we hang parts from the cantilever core. And this one is the larger size of that, connecting between the building. We have the data center here and the bridge connecting between the cantilever core. This one we have the mid-rise residence, which we incorporate the suspended structure with the balconies. And this one is the study that we have done with the typologies of connections of the tower clusters. This one is the topology study of the connection parts and study of the hillside residences and the floor plans of the residence. Thank you.
Thank you. Thank you for the presentation. I think obviously the tectonics are very well taken care of, and I appreciate the fact that you got to such a developed structural solution for the proposal. I have a couple of comments. One is, I think the topic of the edge data center is very interesting and also very prominent. There's obviously, maybe I would have liked you to talk a little bit more about that, in the sense that there is a real need for national ownership on data centers in view also of data sovereignty, and also a reduction of the risk you have when you outsource your data as a nation, like the, say, UK storing cloud in the US, exposure to potential political and geopolitical risk. Let's say China attacking Taiwan, shortage of semiconductors, the US saying, I prioritize my data, all of that is it's all very interesting. But I think the way you addressed it maybe should have been, in particular because you're working with these two agents, and there's the whole kind of logic of kind of economic and real estate underlying logic that you embedded in your agencies. I think it would have been more interesting to say maybe what I would like to say is maybe unlikely that the data center is going to be accommodated in such an expensive tower, right? So, however, if your, let's say, city planning agency would have communicated to the developer agency, okay, I can give you tax relief if you accommodate data centers within the resi towers, which is totally possible. Not only you avoid construction towers for the data centers, but also you increase resilience and distribution of the edge data centers so that they are in higher proximity to where they're needed, and also you reduce energy consumption as well, right? So on the topic of energy consumption and how important it is for data centers in view of especially increased use of AI to reduce the amount of energy they require. So energy is the big thing that I don't think you even mentioned, right? So I think incorporating renewables in the project would have been very interesting, right? Because then you have this elephant in the room, otherwise where's all this energy coming from, and how do I at least contribute to part of the energy that these diffused data centers are going to need. So I think the next would be, for me, the next step would be really, how do you make renewables part of the fabric of the city? I mean, at the moment in the UK, there's a serious problem. Large data centers in the countryside. People living in the countryside hating it. A lot of friction, like, say, around London, a lot of hatred towards these data centers that are primarily serving London. But not only that, but the field of For instance, solar panels, same problem. Consumption of rentable countryside and farming land because of fields of solar panels. So all of this topic being embedded in an urban environment and given some level of solution, how you can incorporate them more in architecture, I think that would be very relevant. Maybe for the next time.
Just a few comments. Yeah, really striking project. I think the sighting was interesting. I think the game setup was clearer than in the previous instances. I mean, and I do like the overall urban patterning. But on that, I would first of all say the vector field, which had a strong aspect of allowing the different sub-centers to radiate their presence through their field and into the other fields, that's got lost a little bit. So there's something to do with probably the towers becoming too circular, the bridging could have been picking up on that. So it looks still interesting. It looks more like a kind of organic. All we have is in terms of center as height, and there's another logic suddenly of these bridge flows. So that would be one question. I had a slight problem with the semantics of talking about latent spaces relative to these kind of signed distance fields. I'm not sure if these even science distance field could even be talked about as an AI. So that because the latent space came out of the neural network language and is applied here, which I'm not sure if makes sense. But I had one problem. I do the tectonic ambition is very strong, and I love the idea of the hanging structures, of the partitioning of these chunks, as well as the lofting between it. So how you use the distance fields, basically, lofting between different floor plans. But I do feel it's what bugs me a lot is there is a lack of rigor with respect to working through on these structural ideas in terms of the cantilevers not always being clear, whether all of these meant to be hanging columns, which one are in compression, some of them seem to be in compression. Then when they kick in, sometimes they kick in with an angle which could be compression, sometimes they kick in nearly horizontal and couldn't be. So I feel there's a lack of, particularly if we work with modularity or let's say with procedural systems. I don't know if they're part of this actually to that extent. It's quite important, although looking at it quickly, first glance, okay, it's there. Looking at it closely, it isn't there. That's a bit of a shame, and I'm not sure if you're aware of this. For me, it's very obviously once you look closer. But overall, I think it's a very beautiful and accomplished project. So.
Well, I'm going to challenge it because, of course I will. I do agree with my colleagues. It is a good scheme. It's beautiful. Of course, early days, it will develop, but as a starting point, there is something in it. What I would like to see is the justification of that shapes. You know, we are focusing on structure, of detail of the structure, generating floor plates, you have beautiful models, you spend a lot of time developing those shapes, and I'm asking you, what are the spaces inside? You know, and especially for residential, it really is important how the apartments work, and you know, because that will make them either fail or win, you know. A developer will sell them if people will buy them, and they need to like the space inside. So I would really like to see a floor plan which would prove that all these, you know, beautiful shapes make sense. These, yeah.
Yeah, so currently we applied the SDF logic and latent space on our plan morphologies and blending the towers, but we could have applied it in the interior spatial program, as you said as well. But right now we've explored more of a broader term in terms of blending the towers and maybe using it more on an urban scale. But latent space, if you meant the differentiation between why we are using latent space, if I've understood correctly.
Is it the right phrase to use?
What I'm trying to say is that, you know, I look at those shapes and I can see every floor being different, which means on each floor you have different apartments. And I let you bet that some of the floors will not work commercially or, you know, physically. So it would be good to see how you actually arrange the interiors, and then maybe you come back to the original shape and you will optimize it. You know, I say it to all of my team. Whenever they create these dynamic shapes, you know, leave it, resolve it, and then it will go back to more vertical, which is good. You know, architecture doesn't need too much of dynamics, especially when you look at it from ground level and the perspective comes into play. You know, you can somehow optimize it.
A couple of comments from me. Maybe developing a large piece of city like this, I have the feeling that the parameters or that you have considered as your basic design criteria, which is firstly the game between real estate prices and development, kind of a very commercial game, and then you try to bring in this sort of data center question and how to accommodate it within the city grid. But there is a number of questions raised here. Is the data center the only thing that a city should consider, or are there other issues that one would dare to explore? I think there is a tremendous amount of issues to do with sustainability in high-rise buildings that remains completely unexplored here. You know, the atrium, the passive ventilation inside buildings, double facades, the way all these buildings form themselves to provide differential functions, not only differential form. And I think when it comes to the issue of form, it's a little bit, I would say, disappointing to see that the towers remain so generic. So I think the bridges go a long way towards creating some of that much needed diversity, but judging from the, you know, ellipsoidal plan of the tower, I think somewhere this project sort of falls short in my eyes. I think there could have been a lot more investigation, and I'm not saying try to simulate like a realistic looking city, but I'm suggesting developing an understanding of what policies a group of buildings, like 200-300 buildings, could have in terms of facade, in terms of atria, in terms of heights, in terms of open, elevated or sky spaces, etc., to be able to invigorate this urban fabric a lot more beyond the idea of the bridging section. So I'm not so much worried about the structural feasibility of these sort of exoskeletals. I think that can be eventually resolved. But I'm more worried about the civic spaces, the other functionality here. And that diagram or this model here with the bridges, you highlight them in blue. And I think it's interesting that you're beginning to consider what the impact of the bridge is on or how you network a series of buildings, to put it simply. But I think, again, you haven't gone far enough to see how this networking of buildings could yield other realities of urbanism. So, for example, all the connections between your buildings here, with maybe some very, very few exceptions, are a single bridge running from what's essentially a tower to another tower, right? You haven't yet evolved into a three-dimensional urbanism whereby all these buildings become even sectional loops of movement through the city, so you can begin to create a lot more of those other conditions where you have elevated plazas, elevated avenues, pedestrian streets, shops on level 15, kindergartens. And I think this leaves unexplored the possibility of looking at the stock of a city as a kind of a public shareware that can be thought of as a kind of an urban fabric that goes beyond individual property. You see? And I think once you start opening up these boxes, I think you can discover a lot of potential for developing network city fabrics in a way that goes way beyond the individual tower projects. And I would have loved to see a little bit more of that, to be honest. Okay?
Yeah, that's quite a lot. I guess just to add to that framework that Chris has just outlined, I actually was quite, beyond the master plan and the comments that have already been shared, I was quite interested on the specificity of the plan. For me, obviously the plan is quite an issue in tower design, and a very specific, the relationship between the tower, the structure, the core, the circulation, the efficiency of the plan, and there's a rich kind of body of knowledge to investigate that could obviously concatenate and kind of link to the issues that Chris is raising, and the potential of this very interesting initial diagram. I agree, is a bit limited in terms of its shape and its expressivity, but very interesting in terms of its layering and I think all the kind of granularity. This a much deeper understanding of the interrelationship between the plan, the structure, the circulation, the core, will probably give you the tools to start rethinking or closing the loop, right? For me, it felt a little bit linear. You had a master plan, then you had a programmatic arrangement, and then you put a structure into it, and then you start solving your issues. But of course, I'm much more interested in the non-linearity of the problem. Can the structure then influence the plan? Can then influence the tower? Then influence the position of the tower, and so on. Kind of working backwards from the micro problem to the master plan. Could that be another layer of information that can address some of the issues that I think Christos and others were pointing out? I think that also a very interesting part of thinking.
I want to go back to the beginning of your presentation, because I think the important bit is that what you're presenting is really an infrastructure to develop urban form. And it's really just testing little elements of that infrastructure at this moment in time, right? And there's only 2 players, and there's obviously many, many players missing. They wouldn't make it a city, right? And there's a limitation, which I think is just, I read it really as a research project that is trying to present a new idea-generating infrastructure, if you like. That is a negotiation process that is technically aided, right? And so, in reality, of course, there will be much more than one player. In reality, this is also a procedural. I can see most of the things that you just mentioned. If you would think this further, right, then you would build something, and then something would react to it, and in a much more complex matrix than here. But again, what I do value a lot is that you actually do the hard work of trying to almost work from first principles by looking at the technology and trying to understand it and in a way feel it, what it actually does. And I think that is going to be a super important skill in the future, where it's not that the tools that we design have an impact on us and on how we design, and since we are spatial designers, they actually have an impact on how the world will be designed, right? And so I do think we have to spend a lot more time on that level of engaging with the technology, with the tool, and creating that feeling or that different way of navigating even, right? I think in the future we are not going to move levers and navigate in that way, right? Maybe the way we're going to navigate the AI is going to be through emotions, and it's going to be through sound, and it's going to be through, different ways. But all of that can only evolve if we engage with the technology on that kind of, basic level, and really start from, in a way, trying to understand the first principles of the technology. And then we can add complexity, and then we can add many million things on top of it. But if we don't do that first bit, then we cannot do any of that, right? And so in that sense, I think it's a really brave studio, and I think it's a good process, and it's hard, I think, for you as students to get your head around this, because it's so different, and it's also, I think, hard for us. I'm a bit older to actually wrap our head around that, what it actually means, right? But yeah, the only way to do that is to start from first principles and experience it and feel it, I think, and that's I think you're doing that well. So, yeah, thank you for that.
Thank you. And jumping on what you actually just said, I was wondering, going a bit deeper into the basis of your proposal, which is actually integrating edge AI data centers into the city, how that would modify a city plan, not just based on how it would radiate, but asking maybe yourself a lot of questions on the access to resources for data centers, cooling power, electricity, but also maybe solving a lot of questions about the data safety, for example, like, since you integrate data centers into the city, and there's this idea of decentralizing maybe the computation power and storage, that maybe it could be interesting also to push forward your thinking on how that actually influenced the city development based on maybe the computation need within the city, and how these data centers are progressively built according to the need of a city in a specific location. These are just thoughts, but so that's about the maybe more the horizontal planning, and then it would have been super interesting to see also how putting these centers at the basis of your towers also benefits from how the rest of your programs benefit from it. The potential interactions in terms of cooling or heating, and how this would actually work as a global ecosystem, and how that would benefit from it.
Personally, I'm quite impressed by your idea of using data center to create a master plan. A couple of months ago in Korea, the data center was on fire and everything stopped. It was a national data center, and we couldn't do anything. I mean, national insurance, medical insurance, everything stopped. And then governments start to sort of divide a big data center to the couple of small ones. And now I think that they are building data center on the suburban area because it doesn't create any value. You need a data center, but somehow you can't sort of build it actually in the city center because the rent price is so expensive. And the way you try to build the master plan here is, I think you try to sort of look at the kind of the rent value and the revenue you create. Even though it's kind of preliminary, I think it's a really good start actually, to reach kind of sensible the master plan organization in the city center. I think that's kind of one package. I think you have to probably kind of look at more. I mean, what kind of the technical requirement is necessary to persuade everybody here actually, to justify the data center is, can sit on the city center. And I think you achieved a certain level, and I think this is kind of, for me, I think it's enough to start to explore at the next level. I think you proposed also another package, which is architecture level here, which, with a beautiful tower on it. And we have a couple of comments about whether the floor plate is sensible, in conjunction with your data center on the ground level, because all the MEPs and, the plans have create kind of all the complex. against probably the data center. It's kind of paradox because if the upper floor is on fire, I mean, you know, the ground floor is in danger, you know, which is kind of very critical issue for the data center. So I think that if we probably kind of work again and in conjunction with the data center ground level and upper floor, and what kind of architectural organization can be achieved on this level, then I think that we can probably get the same level with master plan and architecture. Whether we gonna have this data center in the city center and actually generate the urban space and the life there. So I think you actually successfully asked the good question for everybody here, and that is kind of something I think I'm very impressed about it. Thank you.
Yeah, I think I mean all these questions. I really love the fact that there's diversity of questions that are being raised. Everything from tectonics and hanging systems and structural ideas, all the way to the politics of data sovereignty and using of data centers as an economic catalyst and so on. And why I like it is because that in one way at least hints at what AI can do within architecture. It's we can ask two separate questions, like when we talk about AI, what new capacities does it bring? But we could also ask what more can we do? And you're already showing as a team of three, most of what we see came after the June review. And so that to me is quite impressive that AI now allows us to do more, right? We can try and do things that previously would have taken any one of these scales, any one of these topics would have taken 3 students at least a year. And so to me that is hinting at what we potentially could be doing in the next 3 to 5 years, where a lot of these integrations can be made to address urban challenges, whether it's data center or urbanization or any other. I think it gives me a lot of hope and idea that things that we've been building up for 2-3 decades now can actually be applied practically to address contemporary issues, whether it's urbanity or I mean, not to say any of it is resolved, but the fact that we can have this conversation across scales to the degree that there is some credibility, right? There is something on the table to be able to discuss structure, something on the table to discuss data centers and how they may be located in an urban fabric and so on. So I think I really appreciate that fact that you really try to address things from first principles, as Jan was saying, and try to see how far you can go. And so this is a glimpse of what can be achieved in with a group of people within a short span of time. And I think that is to me representative of what we could aim for. You raise the bar compared to last year. Also, there was 1 or 2 teams that tried to raise the bar, and I think this year you have done that. So yeah, and so in that sense I commend you, and I also thank you for kind of believing in that. Yeah.
Okay, I think you guys have profited from many different kind of perspectives, which I think is an opportunity now for you guys to take stock of that. How you guys want to do that, I think, is on your own terms. The one thing that I would say is the data centers, the subject around all of that stuff, I think it was an important starting point. It set the table, it set your game space. The one thing, though, that has remained unsaid is the idea of the landscape, the urban ground, the strategies of, let's say, for example, when Manuela is saying where the energy is coming from. I think if you really start to see that it's not a tabula rasa, that ground space, to be honest with you, the data center doesn't have to be somehow in line with the actual tower footprint, that we have the capacity to link these things with much larger kinds of flexibility than the way that you guys are showing it. Because I think you've over-constrained in this iteration, the idea that it has to sit within an elevated kind of ground platforming, which is part of the language and the legibility of how these towers are sitting next to each other. But I feel like when some of these towers are really close together, some of these like ground first elevated podiums, these could be underground. Landscape here doesn't have to be green. Landscape can be really an operational and a function of cooling systems, solar systems, however you guys want to use these things, instead of thinking of the infrastructure as something completely outside of the system, that's the thing that's going to charge this with a certain vitality that then could make the argument that these things could be embedded within an urban context. And then I think that, you know, you're on a subject that is interesting, but then there's also the counterpoint to that, that these technologies and these data centers are changing. And so then the aspect that you need to speak to is like, do you incorporate this idea of change? Is this landscape really a game space that is really changing? The AI aspect, I mean, Sajay is very much a proponent of that, allowing you to build variation. We used to do that with just through strict rule-based generative logics, right? Now the issue is, like, this is supposed to be a learned system. This is a system that will problematize some of that stuff, create kind of options. That optioning, I think, is really important, where we can really start to play radical difference with some of these constraints to be able to find a fitness criteria that brings some novelty to things. Because I think somehow, like, at the moment, you guys quite domesticated the ground to the point that the ground is not really part of this kind of really urban life. And in this case, to be honest with you, everything that happens at the city level is given over to machines, or to, let's say, the brain behind this machining and the algorithms and our so-called social interactions and so forth. So I think, like, the way that you think about the city should be profoundly different. And it's not just about allowing us to do these things, and it's not just for the facility of it. I think, like, it should really start to make an argument about what makes this city more than a collection of buildings and infrastructure. I think, like, the bridging is slightly a tentative thing, because in some cases, in some of this, you have plates, you know, like planes of reference that are going through 3 towers or 5 towers, but you don't feature that so much. We talk a lot about the bridge, but I think that that becomes like a default kind of connection between towers, which isn't necessarily about communication. It's just an elevated street. So I feel like, you know, use, I think, a lot of the feedback that you guys have had to look at your project differently. And I think if, you know, Sajay's kind of thesis is correct, you should be more inclined to then now really build in parameters to let the machine version things that are a little bit more unexpected. And I think the same can be said about how you occupy, you know, you come up with a flexible system for hanging. And I think the same thing. Can we version really radical difference of how things are distributed within that? So we don't have the classical commercial, residential, that we start to hybridize things, and that you allow this thing to actually, you know, challenge you. You don't see it as something that's just facilitating some form of optimization or some form of clarity, but you guys really sort of start to embrace it and now allow yourself, I think, the ability to just enjoy the process of it actually offering you something. Let it work harder for you. And I think you need to be using, I think, that synthesis between yourselves to be able to then start to be very clear about actually what are the new metrics that are going to start to become part of the evaluation criteria. Then I do agree with Sajay that we could start to introduce something that we haven't done before. But if it's just about output, about form, about general tower types and urbanism, we've been doing this for 30 years. So the point is, what's different? And those differences, I think, need to be somehow made legible, so much so that we start from that and almost reverse engineer what we kind of understand of the city. And that's how I take Jan's point. But I think Manuela's point about where all of this is being powered and sourced and cooled and all of these things is not a minor point. I mean, the beach landscape version of this is a slightly misfit in terms of the visualization of what this thing actually really wants to be. So I think, just embrace some of those things, and then I think you can creatively find a way to manage that. So it doesn't look like something that's just attached on, or a bunch of, solar cells that are just distributed in the landscape, because nobody wants that. Because to be honest with you, nobody really understands how dependent they are on those things. And they just want to push it to somebody else's backyard. But I think having some integration of all of these things is really meaningful, and I think it's a good way to conclude the day, because this is only round one of 2 rounds, which will continue tomorrow. And tonight we have Claudia giving our talk, invited keynote, which will happen in about 15 minutes, give or take, or 20. So I think with that, I think we just all, from the staff of the DRL and the students, want to thank our critics for the conversation. I think it's been a really good start to the 2-day event. So if we can thank them with the thing that you guys do, the clapping. I think that would be great. And for those who have stamina that'd like to join us tomorrow at 10 a.m., same place, same time. Thanks so much, guys.